So first of all, let me show you the content that we are going to cover. So if you search like CCIE EI lab exam, right? So if you search this CCIE Enterprise Infrastructure lab exam, and you just open this first link that we have here, CCIE Enterprise Infrastructure exam topics, you click on this link. This is the content that we are going to cover. The content that we will cover is going to be focusing on this Enterprise Infrastructure version 1.1. So recently on 20th September, they revised the content. So current CCIE Enterprise Infrastructure content is going to be version 1.1. Earlier it was like 1.0. Now we are going to start this version 1.1. After 20th September, they have revised the content of like almost everything. So we will be following the new content of exam version 1.1. This is what is expected for you to know from the CCIE Enterprise Infrastructure lab exam point of view. Also remember, the things that we are going to cover here is also going to cover the encore topics, like the written exam that we consider. So if you want to clear the CCIE lab exam, you first have to take the core exam, and then you have to take this lab exam. Core exam basically works as the written exam, right? So core exam works as the written exam. So you first need to pass the core exam, then you can attempt the lab exam. So that core exam for the enterprise track is known as the encore. So encore exam you have to take first of all. Once you clear the encore exam, you will be eligible to go for the lab exam. In the encore exam, however, encore exam works as the written exam for both of the things. It works as the written exam for CCIE Enterprise Infrastructure and like Enterprise Infrastructure Wireless. So there is also a wireless certification, Enterprise Wireless. So like there is also a certification for CCIE Wireless, which also comes under our CCIE track, our routing and switching track. Earlier it was known as the routing and switching. So nowadays we have like CCIE Enterprise Infrastructure and we have CCIE Wireless. So this encore exam actually works as the written for both of them. Like we can attempt the CCIE Enterprise Infrastructure and we can attempt the CCIE Wireless exam after attempting this encore exam. Which means that this encore exam will also have in your content, the encore exam will also have the topics of wireless, which we are going to not cover as a part of our CCIE Enterprise Infrastructure content. Our CCIE Enterprise Infrastructure content is purely going to focus on the enterprise part, not the wireless part. But most of the things, I would say like 70-80% of the content of this encore is completely going to be covered in the enterprise infrastructure curriculum. Except for the wireless, I would say, except for the wireless part that we have in the encore, there are like 4 or 5 topics. There are 4 or 5 chapters of the encore that we are not going to cover as a part of our enterprise training that is dedicatedly covered in the like wireless training. After that, like we will this encore exam will be like you will be able to attempt the encore exam once you cover like these extra 4 or 5 topics as well. So enterprise infrastructure exam is before you attempt the enterprise infrastructure, you need to take the encore. So all these topics that we have here, these topics like also there in the encore exam. So you will also be able to take the encore exam after you cover those extra 4 or 5 topics of the wireless. Then you will also be ready for this encore exam as well. Right. So for the topics that we are going to cover is purely going to focus on this enterprise infrastructure lab exam that we have. So we'll be covering the topics from here. Right. So enterprise infrastructure version 1.1 lab exam. You can download these topics and you can keep these topics with you on regular basis. You can see what topics we have covered and what topics are actually left. So total 5 parts are there that we need to go through as a part of our content. So these 5 parts, these 5 topics focuses on the network infrastructure, software defined networking, transport technology, infrastructure security, and automation and programming. Currently, we are going to start the CCIE routing. So we will focus only on the content that is of routing from this entire curriculum. Only the routing content we are going to focus as of now from this entire content. Once the routing is done, then you might go for switching, then you might go for SDA, then you can go for like sd-wan, then you can go for the additional topics. The content that we have here, it is going to focus on currently we are going to talk about the routing first. So routing part is covered in this network infrastructure part. So if I expand this network infrastructure part, it is 30% of the entire content. In this 30% of the entire content, we will talk about the routing, and other topics such as like switching and all. So if I expand this, like this network infrastructure, here we have topics related to the switching. So first thing first, like here we have switching concepts, switch administration, layer 2 protocol, VLAN technology, ether channel, spanning tree. These are the topics that you should know from the switching point of view. Once the switching part is done, then you can go for the routing concepts. So this is what we will focus on as a part of our content at the moment. So routing concepts we will focus on. So in the routing concept, we should know about things such as AD, static routing, policy based routing, VRF, VRF aware routing, route leaking between the VRF using route maps and all, route filtering using ACL, prefix list, filter list, all those things, redistribution, authentication, BFD, MTU. These are the basic routing concepts you should know about. Once you have covered these basic routing concepts, then we will talk about protocol EIGRP for IPv4 and IPv6, EIGRP adjacency, best path selection, EIGRP basic general operations, EIGRP classic mode and the named mode, how the convergence, optimization and scalability is done in EIGRP. So this is what you should know from the EIGRP point of view as a part of your CCIE Enterprise Infrastructure curriculum. Remember that throughout our training, we will focus on the content. So whatever things are there in the content, we will complete it for sure. Additional a few things might be covered, but it's not like we will complete entire EIGRP. Just to make things clear, it's not like this is entire EIGRP. This is like everything that is there in the EIGRP. It's not like that. It is what we should talk about from the content point of view. It is what is expected for you to know from the exam point of view. So we will focus specifically on these topics. Apart from these topics, here and there a few more things like can be covered, but it's not like the entire EIGRP, entire OSPF. It's not like the entire BGP will be covered in our training. It's just focused specifically on the content. Maybe when you go for the service provider content, you might see few more things in OSPF. When you go to the service provider content, you see few more things about the BGP. So we will specifically focus on the content. Whatever is there in the content, we will cover it. All the documents, all the slides and everything that you will get, it will completely focus on the content. So whatever is in the content, we will cover it. If it is not in the content, we will not cover it. Right? So EIGRP, from the EIGRP content point of view, these are the things that we should know. This is what is expected for you to know from the exam point of view. So these are the things that will be covered 100%. Everything we will talk about, like from the EIGRP point of view for IPv4, IPv6, classic EIGRP and the named EIGRP. Then OSPF version 2, version 3, which is another way of saying OSPF for IPv4 and IPv6. Again, OSPF adjacencies, address family, network types, OSPF operations, optimization, convergence and scalability. This is what you should know from the enterprise infrastructure content point of view, and this is what we will cover as a part of our content. Again, it's not the entire OSPF, it's what is in our content. So again, we will focus specifically on the content. Whatever topics are there in the content, we will cover it. So OSPF for IPv4 and IPv6, everything like from the LSAs to the neighborship, adjacencies, states and all that, everything will be covered as a part of this OSPF content. Maybe again, if you go for the service provider track, you will see more topics in the OSPF itself, which you will cover specifically in the service provider track. Maybe when you go to the other tracks such as security, such as data center, you might find other things like in the content, but those things we will not cover here. Since our content says that these are the topics that you should know, we will talk about these topics. Right, so OSPF version 2, version 3, OSPF for IPv4 and IPv6. Same goes for BGP. BGP for IPv4 and IPv6. We cannot possibly cover entire BGP as a part of our content. So this is what we have to focus on from the BGP content point of view. So from the border gateway protocol content, from the BGP content point of view, eBGP, iBGP, neighborship, how to form the eBGP neighborship, how to form the iBGP neighborship, and a variety of concepts regarding eBGP and iBGP, such as peer group, template, stage, timer, dynamic neighborship, authentication, private AS number, then how BGP, once the neighborship is done, how the BGP decides the best path, what are these path attributes, what is the BGP best path selection algorithm, how the load balancing in the BGP takes place, how we can influence the BGP best path selection using routing policies, variety of routing policies to manipulate the attributes, conditional route advertisement, outbound route filtering, communities, multi-homing scenarios, AS path manipulation using local AS, allow AS, remove private AS path prependation, regular expression, route reflector, aggregation, other features such as soft reconfiguration and route refresh. So this is everything that we should know from the BGP content point of view, and that's all that we will talk about. Again, this is not the entire BGP. This is not even like the 50% of the BGP. This is hardly like 30-40% of the BGP content. So rest of the BGP content you might see in the service provider, in other tracks. We are again not going to cover everything about the BGP. We will cover the things that are part of our content, our CCIE enterprise content. So this is what is in the content, and this is what we will cover. This will be covered for both IPv4 and IPv6. Right, so IGP protocols and EGP protocols as per the content. As per the content, IGP protocols and the EGP protocol as per the content for IPv4, IPv6, we will cover. Again, whatever is in the content, we will talk about it. If it is not in the content, we will not talk about it until it is important from the lab exam point of view. There might be a few things. There might be a few things that are not written here, but they have asked those things in the exam. We will talk about it. But other than that, we will specifically focus on the content. Right. So this is what we should know. This is what we will talk about. So this is the basic like routing. This is like routing from IGP and EGP protocol point of view that we will cover. Once the routing part is done, then we will move on to the other topics. So this is like IGP and EGP from the IPv4 and IPv6 point of view. This is like unicast routing. This is like IPv4 and IPv6 unicast routing that we will talk about. Once it is done, then we will move on to the next topics. Any doubts so far? Anyone? Any questions? Anyone? Let me know. This is the routing part. This is the basic the base routing part that we need to cover. Once we are done with this, then we will talk about the other topics.
So to understand BGP in more details, so in which part of exam it will cover?
Service provider. We will cover as a part of our content, we will cover pretty much at very moderate level of BGP. Like we will be able to cover you will be able to manage like a small to medium or even a little bit large infrastructure based on BGP. That will be okay. But some other concepts such as traffic engineering and those things, like if you want to know about, those are specifically covered in the service provider track.
Hello. Yeah, hi, I'm Rahul Sharma. I just want to ask something are there any prerequisites before we get into the training?
We'll talk about it. I will definitely let you know what things you should know before we can begin our content. We'll just in a moment we will talk about it.
Okay.
Hi.
Yeah, hi, Suji.
Hi. So from a switching part of view, if you remember, I have already taken the switching course. So it will be entirely again repeated or
once the routing part is done, then we will move on to the topics of like sd-wan, sd, then we will come back to the switching. So if you are looking for like the switching classes again, then like once this routing part is done, then we have like in this morning 8 to 10 time slot, we have the SDA batch, software defined access batch. Once that batch is done, then we will talk about the switching part again. So yeah, in this time slot, the content will revise like again and again.
Okay, and in terms of the lab, so everything will be repeated.
Yeah, definitely same thing, exact same thing that we have covered in the content. It will be repeated definitely.
No, from switching part of
same. When we talk about the switching content, yes, when we start the switching classes, yes, the same labs will be repeated that we have covered in the previous classes. Yes.
Okay, thank you.
Right. So once we have covered this traditional routing part, once this traditional routing part is done, then we will move on to the topic of, we'll not talk about software defined networking. We will move on to the topics of transport technology. So remember that 60% of the content that we have in our current enterprise infrastructure, it is focused on the routing and switching. So in the 60% of the content, we have our traditional switching, then we have our routing. So rest like 40% content, like in rest of the 40% content, 25% is the software defined networking, and the 15% is like programming and automation. Right, so currently we are talking about this one, 60% of the traditional routing and switching content. So once we are done with this traditional routing part, once this traditional unicast routing is done, then we will talk about the multicast routing right here. We will talk about multicast routing. Multicast routing we will cover. Multicast routing, the layer 2 multicast, the layer 3 multicast, layer 2 multicast based on protocol IGMP, layer 3 multicast, then we will talk about the based on PIM protocol independent multicast. So once the unicast routing is done, then we will talk about the multicast routing. Multicast routing for both IPv4 and IPv6. Not again in very detail, only the content that is there in our CCIE Enterprise Infrastructure curriculum. So whatever things are mentioned here, those topics we will cover definitely. Right, a few things they have removed, such as we used to have this thing called dense mode. They have removed like that dense mode, so we will not talk about dense mode. We will just have a we will just get a generic idea what this dense mode is, why we were using it, but we will not practically configure it. Since it is no longer part of the content, we will not talk about it. We will just talk about it from the theory point of view to know the pros and cons of that dense mode, and then we will move on to the sparse mode, sparse dense mode, and the other things. So the multicast, once the unicast routing is done, then we will talk about the multicast routing. Once the unicast and multicast routing is done, we will be done with our like traditional routing part. So routing for IPv4, IPv6, unicast routing means like routing of class A, class B, and class C addresses, and the routing for class D addresses. Like so, unicast routing and multicast routing. Once it is done, then we will move on to the next topics, and we will not cover the software defined networking. After that, we will talk about the transport technology, where we will talk about VPNs. We will talk about VPNs based on like GRE DM VPN and VPNs based on MPLS. So like VPN basically is more like a way by which we can connect our variety of branches all together with like headquarters, data center, and of course to each other as well. So what are these GRE? What is this GRE technology to connect like the headquarter branches together? What is this DM VPN, single hub, dual hub DM VPN? Then what is this MPLS technology, MPLS based VPN? So this is 15% of the entire content. This 15% content focuses on three things: GRE, DM VPN, of course, like IPsec, then GRE with IPsec, DM VPN with IPsec, and then MPLS and MPLS based VPN. This is like, and again, this is for both IPv4 and IPv6. So for both IPv4 and IPv6, we have GRE, DM VPN, IPsec VPN, then MPLS, and then layer 3 VPN. So as a part of our content, again, we will talk about these things. And again, just to tell you, this is not like the 100% of the like DM VPN, 100% of the GRE, 100% of the IPsec, 100% of the MPLS. No, it's not like that. It is what is in the content. So as a part of the content, we will focus specifically on basic DM VPN connectivity, basic GRE, and the basic MPLS and MPLS based VPN. We do not have in our content things such as like layer 2 VPN. So we will not talk about layer 2 VPN. We do not have any 6 to 4 tunnels, like 6 to 4 tunnel NAT prefix translation. We do not have any of those concepts, so we will not talk about those concepts. Right, we have just basic dual hub DM VPN. We do not even have like a very we have IPsec connection, we have IPsec like based tunnels, but we have IPsec tunnels based on only pre-share key. We don't need to use any certificates also. So if you want to know about those things, either you go for the service provider track or you go for the security track. In the security track, things such as like GRE, DM VPN, IPsec VPN, these are covered in very detail. But when we talk about like this MPLS VPN, MPLS and MPLS based VPNs, these are covered in the service provider track. So it's more like the overview that we are going to get. It's the overview that we are going to get from our content point of view. This is like the basic things that we should know from the lab exam point of view and from your production point of view as well. So basic GRE, basic DM VPN, basic IPsec, and basic MPLS and MPLS based VPN. Rest of these things, like in advance, These things are covered in security track. These things are covered in the service provider track. So you need to go for the service provider or the security track to know about in more details about GRE, TM VPN or M+based VPN. We will cover, just in a moment, I will show you the index that we will cover. You will get the idea from there, but we will limit our content. We will limit our content as per our official document. So this is just 15% of the entire content. We do not need to spend like a lot of time, but as a part of our content, we will at least cover everything that they have mentioned in these 3 points. And once this is done, once this part is done, we will be done with our like routing curriculum. Just one topic will be left, that will be quality of service. Once this part is done, then we will talk about this thing. We will talk about this quality of service thing. And in the quality of service, if I expand that quality of service topic, it is right here. So this quality of service, actually, if you take a look, this quality of service is in 15%. So part number 4, infrastructure, security and services, it is 15% of the entire content. And in this 15%, we have total 7 sections. In this 15% of the content, we have a total of 7 sections. So every of this section is approximately like 2%. So quality of service is like only 2% of the entire content. So this is what we will talk about from the QoS, quality of service point of view. Again, the basics of the quality of service, basic policing, shaping, classification, marking. Again, we are not going to cover like everything about the quality of service. It is part of like voice video collaboration basically. So you want to know in more detail about the quality of service, opt for the collaboration content. In the collaboration track, you will know there was a dedicated certification for the quality of service. Nowadays, they have included those topics in the collaboration content. So you want to know in more detail about the quality of service, you can opt for the collaboration content. But as a part of our content, we will talk about like the quality of service, how the classification marking is done, the commands, variety of like options that we get in the classification and marking. What is this N bar? What is like marking at layer 2, marking at layer 3? What is this like policing, shaping? We'll talk about all those things. You will get the idea about each and every topic. But again, it is not going to be everything about the quality of service. Hardly, I would say it is going to be 30-40% of the quality of service. Rest like in more detail, other things you have to opt for the other tracks where these topics are covered in very much detail. Right. So again, whatever is in the content, we will talk about it. And you can refer to the official documentation to find out like what level you should go through, what level like of the content you should cover as a part of our exam. We'll talk about that in a moment. But once our routing and switch, once our routing part is done, once our like unicast, multicast routing, transport technology, once all that part is done, then the only topic that will be left is the quality of service. And once this topic is done, then we will see if any additional topics are there. Additional topics such as, for example, NAT here, NAT. So NATing is covered as a part of the routing content. DHCP will be covered along with the IPv6. So these additional topics such as DHCP, such as NAT, these will be covered. These will be NTP here, network time protocol. So these topics will be covered at the very end of our content. Then like things such as FHRP, it is covered in the our switching classes. Then we have like these things are covered in the switching classes. So like not everything from this chapter number 4, not everything from this unit number 4 will be covered as a part of our routing, because a lot of these features are the switch security features. So these topics are covered at the end of the switching curriculum. So once our routing part is done, once this part is done, then we will see what additional topics we need to cover. Topics such as like quality of service, topics such as NTP, then we have topics such as like DHCP, NAT and these things. And then we will conclude, then we will finish our entire routing content. So we will be focusing on, what I'm trying to say is that from this entire content, we'll be focusing on that 60% of the traditional routing and switching content, which is there in our routing. And then for the rest of the content, such as, for example, SDN, software-defined networking, we have dedicated classes of the SDA, we have dedicated classes of the software-defined WAN, Here we have like recorded sessions for these infrastructure automation and programming. Not a lot of things they have asked here as well. Just you should know in what format the data has to be represented, like data encoding format, some basic scripting that you can do on the device itself, like what is this EEM templates. Like these allow us to do some basic scripting on the device itself, like you don't need to go for any automation programs for the same. And these things such as interaction with the vManage API, you cannot cover it until you have covered the SD-WAN. Interaction with the DNS Center API, you cannot cover it until you have covered the SDA. So these topics you cannot cover. These topics you cannot cover until you have configured like SD-WAN and SDA. So for these topics, you need to wait once the entire like SDA, SD-WAN content is done. Then at the very end, you can go for like these additional topics. Just the basic things they have asked here. Like here they have asked you to use the ways to interact with the vManage, which is the SD-WAN controller, to the DNS Center, which is the SDA controller. How we can use these tools such as Postman to interact with the DNS Center APIs, interact with the vManage APIs. So these topics you cannot cover until you have covered the rest of the content. So we will not be focusing on this one at the moment. So we will focus on these 4 chapters, these 4 topics that we have, these 4 units that we have: network infrastructure, software defined infrastructure, transport technology and solution, infrastructure security and services. And as a part of our routing content, we will focus only on these 3. Only on these 3, like unit number 1, unit number 3, unit number 4. And from here, only things that are relevant to the routing section of our content, we will cover those content. Then after, we will start like the switching, then we will start the SDA, then we will start the SD-WAN, and then at the very end, this one, infrastructure automation and programming. And this cycle will repeat in this 8 to 10 morning batch. Right, so like before this batch, the switching part is done. So now we are starting the routing, then we will start the SDA, then we will again start the switching, then again the routing. This will keep repeating. So just in case if you miss something, you can rejoin the classes in the same time slot.
Hey, Ravi here.
Yeah, hi Ravi. Yeah.
Good morning, sir.
Morning.
So from time perspective, like duration perspective, it's going to be like Monday to Thursday, 8 to 10.
Yes. It will be Monday to Thursday, 8 to 10. And it will take, I would say, approximately 75 classes to complete everything. Let me show you the index quickly.
Okay, sure.
So it will.
Sorry to interrupt you. Like, do we also receive presentations like slides for these topics that we can review it with ourselves?
Yes. I will. We will now. We'll talk about the documents, right? So this is the content that we will talk about. Now let me show you like the number of classes that it will take for you to complete this entire content, and then we will talk about the documentation, like what documents and everything you will get. So if I show you just a second. So this is the content that we will talk about, right? So So this is like from the routing point of view, this is like this is the content that we will cover. This is like from one of the old classes. So we'll start with the introduction with the routing protocol algorithm, best path selection, right? Then static routing with exit interface, next hop, NAT, VRF, BFD, all these things. So basics of routing, static routing. Then we will start the EIGRP if we can. Then we will talk about the EIGRP fundamentals, the messages, metric calculation lab, then load balancing, convergence, default route conditional advertisement, EIGRP on WAN, stub site. So approximately 1, 2, 3, 4, 5, 6, 7, 8, approximately 9 classes. Approximately 9 classes will be there for like this EIGRP. 9 classes will be there. 9 classes you can consider for like EIGRP. Right. Once this EIGRP topic is done, then we will talk about OSPF. OSPF topic, OSPF like OSPF introduction, DRBDR election, right? Packet types, states, and all those things. All those things we will talk about. So it will take like so you can see like this is the amount of days like that it will take, and this is the topics that we will cover. We will cover like all these things we will cover like all these things here. OSPF introduction, DR-VDR election, then the lab for DR-VDR, then packets, neighbor states, lab for the same, then LSAs. So 1 day for type 1 LSA, 1 day for type 2, 3 LSA, then 1 day for type 4, 5 LSAs, then like inter-area connectivity and all, right? Then type 5 LSA, type 7 LSA, additional commands. So like again, approximately 13 days for the OSPF. And if you are talking about like OSPF for 13 days, like, you might guess like how much in detail we are going to cover the content. So it's not going to be like an introduction class. Actually, it will be like we'll cover the OSPF as a part of our content in like very much detail. So 12-13 classes for OSPF. And then if I talk about BGP, so BGP fundamental, different types of connection in BGP packets, finite state machine, eBGP neighborship, some concepts of GRE tunnel associated with the BGP, iBGP neighborship consideration, full mesh router reflector, peer group, peer template, configuration, synchronization, multipath relax, path attributes. So we'll talk about like 1, 2, 3, 4, approximately 4 or 5 days for the path attributes. Then default route, dynamic neighborship, additional path support, summarization, AS set, suppress map, unsuppress map, attribute map, advertise map, conditional route advertisement, inject map, regular expression, basic regular expression, ACL, community, private community, outbound out filtering, a lot of topics. So you can see from day 28 starting all the way to 47, approximately 20 days we'll talk about BGP. So it's not a like introductory class. Like it will talk about the BGP in as much detail as we can as a part of our content. That's why I said like you will be able to handle medium to large scale infrastructure once these topics are done, right? So it's very much in detail. Then IPv6. So IPv6 introduction, how the IPv6 addresses are allocated, different ways to allocate IPv6 address onto the interface. Then routing for IPv6, static routing, EIGRP, OSPF, BGP, BGP IPv6 and BGP IPv6 over IPv4. There is also a topic called prefix delegation and that. So DHCP and everything will be covered here. So 3-6 approximately 5-6 days for the IPv6 topics. Then we will talk about the VPN. So in the VPN, we have GRE, DM VPN, routing on DM VPN, then BGP on the DM VPN, VRF, like FVRF, we'll talk about it. IPsec, basic IPsec introduction, IPsec like modes, IPsec configuration, phase 1, phase 2, IPsec on the DM VPN, and then the VPN topic like the GRE, DM VPN, and IPsec topic will be done in these approximately 6-7 days. Then MPLS and MPLS based VPN. We'll not talk about L2 VPNs. We'll not talk about sham link. If we have some time, then we will talk about it. But since these topics are not part of our content, we can exclude these. But if some time is left, then definitely we can talk about it because it might be beneficial from your production point of view. So basic MPLS introduction, MPLS architecture, the messages used in the MPLS, then how the routing happens between the PEC without the VRF, with the VRF, L3 VPN, route target import, export, and L3 VPN. Our content focus is going to be L3 VPN. If some time is left, then we will talk about the L2 VPN and the configuration of the L2 VPN as well. So you can see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to 15 classes we can assume for the VPN topic. VPN based on like GRE, DM VPN, MPLS based VPN. So 13-15 classes for the VPN. Then multicast. So multicast and multicast routing. So layer 2 multicast, layer 3 multicast. So a few days for IGMP and a few days for our PIM, protocol independent multicast. 6-7 classes for multicasting. 4-5 classes for the quality of service. So quality of service, what is quality of service? What are the things we can do in the quality of service? Classification marking, marking at layer 2, layer 3, queuing strategies, drop policies, shaping and policing. So you can consider approximately 78, 75 to 78. Let's round it out to 80 classes. Again, because 80 classes you can consider. Why? Because in between, like let's say for example, our EI-GRP topic is done, our OSPF topic is done, our BGP topic is done, or let's say for example our IGP is done. Once our IGP is done, once our IGP topic is done, then one day we will talk about the questions. One day we will talk about like the type of questions that they have asked in the previous lab exams. So like you can consider one day for that. Then once the BGP is done, we will talk about what type of questions they have asked in the BGP in the lab exam, then IPv6 and plus. So you can consider like 2-3 more days. So approximately in total 75 to 80 classes it will take. These are classes, these are not like days. So 75 to 80 classes approximately it can take, 75 to 80 classes, and that is completely subjected to how many number of questions you ask in the lab exam, in the classes. Let's say you are not asking any questions in the classes, then the amount of time that it will take to complete the static routing might get reduced to like 4 classes maybe. If you are able to understand everything like that we are doing in the classes and you are not putting up any questions, then we will be able to complete the content a little bit earlier. But other than that, you can at least consider 75 to 80 classes for this entire content to get covered. Right. So earlier we used to take like way more. Like earlier when we used to have like other topics, it would take like 90 classes, like 75, 80, 90 classes earlier it used to take. But later on, since they reduce the content, it takes like approximately, you can assume 80 classes approximately, 10-15 classes different. And this is just routing. This is not switching. This is just routing. Switching takes approximately 22, 24 days, 24 classes for the switching content. So this is pure routing. This is that 60% minus switching. This is just the traditional routing part that we need to talk about. And you can consider additional 20 to 24 classes approximately for the switching content. So this is what we will cover. You can on regular basis there will be like an Excel sheet. So on regular basis, whatever topic we are covering, that will get updated in that Excel sheet, and you will get the access to that Excel sheet to refer to like what topics we have covered on regular basis. Exact same thing, exact same type, right? So this is like what topics we are going to cover. This is in detail, whatever things we are going to cover. So this entire thing to cover will take approximately 75 to 80 classes. And again, classes will be like, as you guys already know, it will be like 4 days a week, 2 hours a day. So now you can calculate based on the same how many months it will be required for you to complete this entire content.
Hi, I just want to ask one thing. What about the lab part? Are we going to cover the lab after each class, after each topic, or it will be a separate?
Yes. Let me show you that as well. So this is what we will cover. Now coming to like the labs. So once we will have the classes in a mix of theory and lab. So for example, when we are talking about basics of routing, I will have a simple topology. In that simple topology, we will do a basic lab for the routing. Then we will have a topology for static routing. Then we will have a topology for EI-GRP. Then we will have a topology for OSPF. Then we will have it for BGP, for IPv6. We have like different topologies for different like these protocols, and all these topologies will be given to you. All these topologies are in EVNG software, right? EVNG. You guys might already be familiar with this. So EVNG software, I have built a few labs, and you will be given the lab on regular basis. Like once, let's say we start the static routing classes, you will get the access to the EVNG static routing lab. In that lab, you already have IP addresses configured. So you don't need to configure the IP address. I will use the same lab. I will also use the same lab. You will also use the same lab. In that lab, IP addressing is already configured. So whatever things we have to discuss from the static routing point of view, only those things we will cover, I will cover, and you have to repeat that thing in your lab as it is. You will understand the concept that we are talking about in the class. Once you understand the concept, that, okay, this is how we do the static routing, this is how we do the static routing. The objective is to repeat. The objective will be to repeat like the things that we have done in the lab exactly as it is at your home environment. So that when we talk about at the end, when we talk about, okay, these are the kind of questions that they have asked in the exam, you should be like, familiar with those things. Like you should know that, okay, what is the solution of this question, right? So you will be given like these labs of indivisible protocol. Just let me show you like a basic, let me show you a basic topology for our classes. Remember that these classes in the EVNG software, if you do not have the EVNG software, installed on your machine, then I will ask you to have a discussion with Mr. Sugan, Mr. Saurabh. They will connect you to the lab admin that we have here, and she will be able to install the EVNG software onto your machine. If you have the EVNG software, then well and good. You can just import the labs that I will provide you, and those labs you can start exactly the same way as I will be doing along with you in the classes. So you don't have to do it in the classes. Yeah.
Sir, for example, I have EVNG in my laptop. I may need some images for some switches and these things, so I need to get those
You can have
images.
a discussion. You can drop them a message, and they will provide you with all the necessary images that will be required for our classes. They will do that definitely.
Okay, thank you.
So for example, just to give you the idea, I'm still working on it. Like, so this is like all the things that this is all the labs that we will be doing, that we'll be talking about. So this is like purely on EVNG. Earlier we used to do it on the GNS, but as our content got updated, they asked us to do the labs on like iOS 15. So iOS 15 is not typically supported, or not a lot of features are supported in our GNS software. So we will do the labs on the EVNG. So I will advise you, if you have the GNS, then you will need to build these labs in the GNS. I can provide you some labs in the GNS, but those will not be exactly the same labs. So if you want to practice on the GNS, then you have to build those labs on the GNS, and you need to do the configurations of the IP addressing and everything in the GNS. So since like they have asked us to practice on the latest version of the iOSs, and those are not available on the GNS, these are like the topologies that I have built on the EVNG, and you can do these labs in the EVNG. So for example, I will provide you these labs as our content progresses. So for example, this is a basic static routing topology. In this topology, we will cover everything that we should know from the static routing point of view. And it will be like your responsibility. It will be your responsibility to cover all the things that we have covered in the classes exactly the same way in your home environment as well. You will refer to the recording. You will refer to the recordings. You will see what things are going on. You will see like what concepts we have covered in regular basis, and then you will repeat the same thing. You will repeat the same concept. You will basically repeat. You can make your own notes if you want to make, but you will repeat the same things on this EVNG lab that will be given to you. All right, so this is a basic topology for the static routing. Once it is done, then for example, like this is like a basic topology for EIGRP. Right, so this is a basic topology that we will use for the EIGRP classes. Right, so same like if you this is the basic topology that we will use for the OSPF. So IP addressing and everything is already configured. All you need to do is to configure OSPF here. You can fine tune the resources. If you do not have like enough resources on your machine, you can, like in this EVNG, you can fine tune the resources. Instead of giving like 512 MB of RAM, if you don't have like sufficient amount of RAM onto your machine, you can reduce the RAM size to 128 MB if you want to. But since I have sufficient RAM, I will be able to do all these labs on here. So this is basically a basic topology for our OSPF, right? Then I can have, let me show you the, we have like these topologies. Like this is a very basic BGP lab. This is a basic BGP lab where we'll talk about the neighborship and all. And once this lab is done, then we will talk about an advanced BGP lab. Here we have a lab for the BGP. We have OSPF here, EIGRP here, and in the core, we are running BGP. right? So I have already done the like IP addressing. I'm still doing it like this is for IPv6, like so I'm still doing it like I think like up to MPLS I have already covered, but by the time we have reached to this MPLS point, you will get these labs on the regular basis. So once we reach on to that part, then you will get those labs, right? So these are like total, if I say chapter by chapter, like protocol by protocol, we have these labs. These labs will be provided to you as we start the topic. So let's say when we start the EIGRP topic, you will get the EIGRP lab. Once we start the OSPF topic, you will get the OSPF lab, then BGP, then IPv6, right? So static routing. So these are the labs that I will provide you. And then at the very end of, let's say, once the IGP is done, then we will talk about what type of questions they have asked in the exam, right? So there will be a very big topology. In that topology, all the protocols and everything is there. We will see what type of questions they have asked from the static routing, EIGRP, and OSPF point of view, right? So we'll be doing our labs in this simulated environment, EVNG. If you do not have the EVNG software, you can ask Mr. Sugandh or Mr. Saurabh. They will help you with like this EVNG setup. Otherwise, like you can also practice on the GNS, but for that you need to build these topologies in the GNS. I can provide you some topologies on the GNS, but those topologies will not be exactly the same. Those were from the old content point of view. So you can still implement things in that topology, but it will not be exactly the same. So if you want to practice on the GNS, you need to build these topologies in the GNS.
Hi, I have a question.
Yeah.
So we, as you shown, these are individual labs,
yes,
like small labs.
Hmm.
So are we going to do like a full-blown lab where everything is in a real exam environment, like kind of real exam environment where
like
everything is there?
Yeah, we can talk about it. I can show you the topologies that they have asked in the previous exams and so. But doing like since like the topics and everything that we will be covering throughout our content is exactly the same as the questions that they have asked in the exam. In fact, these topologies are very much inspired from there itself. So we can when we talk about these things, you will get a clear idea. I think like I can also provide you with the lab if you want to do it on from your side. I do have some practice labs that you can like download and you can practice. I will provide you with all the documents, all the questions, solutions, and you can practice on that. But I think like these chapter by chapter things that we will cover, it will be sufficient. Like we will talk about like from the full blown topology point of view, like this is the kind of topology that is expected in the exam, and these are the questions that are expected in the exam. And when we are going through those questions, going through those topology, you will get the idea that okay, all these things we have already covered in this theory classes. So you will have the idea. I think like it will not be possible for us to cover the full blown topology in the content. We might talk about it like at the very end of our content, or like in the from the once the IGP is done, then we will talk about it. Once the BGP is done, then we will talk about it. I can provide you with the topologies if you want to practice on that.
Okay, thank you.
Because that thing is anyway done at the very end. Let's say, for example, if anyone is going for the exam, from the exam point of view, at the very end, like if you are going to attempt the exam, there is a dedicated like 10-15 days sessions for the lab exam. There we discuss about the topologies, there we discuss about like the configurations that you need to do and all that. So that is from the lab exam point of view. From the technology classes point of view, these will be sufficient. And since we will discuss about like the type of questions that they have asked, so it will anyway give you the idea like okay, this is the topology, this kind of topology is expected, and these kind of questions are expected. So you will get the idea anyway.
Thank you.
So Ravi here.
Yeah, Ravi.
Yeah, so if we go by the schedule, when do you think we should be able to target the exam in case we need to just put some?
That pretty much depends. Like, have you already covered the SD-WAN classes, SDA classes, programming and automation, and the switching classes. Because if not, you can safely take like 6 months at least for the all the things to be completed. Like you can consider 3-4 months for our routing, 1.5 month for our switching, and then like 1.5 month for these additional topic like SD-WAN, SDA. So 6 to 8 months I would say, like if you have not covered all these like SD-WAN, SDA classes. If you have covered those SD-WAN, SDA classes, then like only routing, if it is left, only routing part is left, then you can safely say 3 to 4 months.
Hi.
Okay.
Coming to the same question, do you think all these topics, all the content that you have shown is much enough for us to pass the exam?
Yes, 100%. More than that. We'll talk about like whatever things we will cover, it is more than sufficient to clear the exam.
And Surendra, how about the prerequisite for this course?
Yes, we'll just come back. Just we'll come to that point. Yes.
Yeah.
So definitely, whatever things we will talk about as a part of our content is more than enough to clear the exam. Remember, we are still talking about routing. You still need to go from the SD-WAN. You need to still go for the SDA, automation programming, those things, but 100%, yes. Because when we talk about like these old questions, you will get the idea, the level of knowledge that is required for you from the lab exam point of view. You will see that they don't ask very hard questions. It's all about in the exam, it's all about in the lab exam, it's all about time management and how fast you can do the solution, right? So they don't ask like very hard questions. Like for example, they have not asked things about communities. Never. They have not asked about like IPv6 like prefix delegation. Like they have not asked about L2 VPN. They have not asked like anything in very like very technical. They have not asked about that thing. Like just the basic things. It's all about like time management. How you can complete the lab in 5 hours. So yeah, I would say that it will be like more than enough from the content that we will cover. The 60-70 classes, 70-75 classes that we will go through, that is more than enough for you to clear the exam. Considering the point that you regularly do the labs, whatever things we are doing in the classes, you repeat it as it is. You clear your concepts, whatever things we cover on the regular basis. Yes, definitely. Right. So this is the labs, and this is how we are going to do the labs. Any more questions, anyone, from this content and lab point of view?
Surendra, so do you see, considering the current curriculum, do you see any future, any modification in the program or in certification lab? What are your views on that?
As per Cisco, let me show you. So by the way, this link I'm putting in the chat, right? You guys can take it from the chat. And I also have a WhatsApp group for the CCIE Enterprise Infrastructure. So after like a few classes are done, after like at least 3-4 classes are done, once it is like once we I get like a final like, okay, these are the candidates that we will 100% join the classes, then I will share the link of that WhatsApp group, and you guys can join that WhatsApp group. And just in case if you are doing some lab and you are getting stuck in somewhere, you can post your questions on that group, and I'm very much active on the WhatsApp, so you will get the resolution. Of course, if I'm not in the classes, so you will get the resolution on there as well. So once 3-4 classes is done, then I will add you guys in the WhatsApp group as well, where you can put up your questions and all. So for like meanwhile, you can just take the link from the chat, right? So this is you download it. You download this content and keep it with you, so that there is a track of the topics that we are covering, so that nothing is actually left.
Can you share that Excel as well? All content device.
That is actually on the drive. I will share you a better one. Wait. So this is on the drive. Actually, if I download, the formatting will be go here and there. So I will share you a better one. Just wait.
Sure.
So coming to the point of the changes, yes, you can always expect the changes. So Cisco has officially, let me open one more link here. So here is like the another one more link I'm pasting in the chat. You can refer to this one as well. So this is like Cisco certification roadmap, and this is the roadmap. Like earlier, what used to happen, actually the content used to get changed in every 3 years, because that's the validity of your exam. Every CCIE exam is valid for 3 years. So earlier, what used to happen, the content used to change in every 3 years, right? But now what they have done in 3 years, like technology goes like from here to there, like technological changes are like very much like in those 3 years time period. So what they have done, what they have announced, actually what Cisco has announced, that now they're not going to do the changes in every 3 year. Instead, they will do the changes in every 1 year. So they have created like this, for example, cycle. In the cycle, like they will review each technology, then you will announce the changes, and they will publish the changes. So you can consider like six months to 1 year. In every 6 months to 1 year, it is expected for you to see here and there a few changes. However, those changes are not going to be very big. So if I scroll down, see, for example, in quarter one is October to August to October. In quarter one, what they will do, they will review like the data center and collaboration. In quarter number 2, which is November to January, like here, security and enterprise. So in quarter number 2, they will review like do we need to do any changes or what, right? And then quarter number 3, quarter number 4, then they will, if any changes needs to be done, they will announce those changes, and then after 6 months those changes will be in effect. So earlier, the changes that used to be done in 3 years, now they will do the changes in every 1 year. However, you don't expect like, for example, if I go for like here CCNA, they did not make any changes in the CCNA, for example. However, if you go for the enterprise, they did make the changes for the enterprise, because enterprise content was very much similar from the past, like 1 or 2 or 3 years. Since the content launched in 2020, everything was exactly the same. So it's like they have changed the content to 1.1, 1.1, 1.1. SD-WAN is 1.2, by the way, 1.1, 1.1. So you should keep an eye on this. You should keep an eye on this link for like any upcoming changes. So yeah, now we can expect the changes in every year, but those changes might be less than 20%. Those changes might not even they might not even make the changes actually, right? Such as, for example, for CCNA, they did not make any changes. So CCNA content is exactly the same since 2020. It's still going on exactly the same. But for the enterprise content, for the security, for like collaboration, for the service provider, like, for service provider, they did not make any changes. So it's not like they will 100% do the changes, but it is expected to see the changes in every 1 year nowadays. So 1.1, 1.1, 1.1 basically means less than 20% content change. Less than 20%, less than 20%, less than 20%. Right? So we have version 1.1. So if I click on this button, release notes, right? Here I can here they have that where is that release note? Here they have that that page where they say that, okay, what things we have removed and what things we have added. Here, CCIE release notes. Where is that? So here, if you click on this release note, this is the changes that they have done. This is a PDF that shows you the changes that they have done. And these changes, like what changes are done from the content point of view. So these things they have removed. From the network infrastructure, they have removed this VLAN database, VTP, Ether channel, multi-chassis Ether channel. They have removed these topics. These topics were added, right? Then they have removed these topics like fast convergence, fast reroute. They have removed OSPF version 3 address family. They have added OSPF loop free alternative. They have removed. They have removed like version 1.5 F multipath add path support. They have removed. Right, so they have done like these things they have removed. So they have done more removal than like adding these things, right?
Is it because of those technologies are obsolete or something?
Exactly the point. Such as, for example, since SDA is coming into the market, there is no need for think protocols such as like VTP or so. Since in SDA it is recommended to have the routed access layer, everything at the up to the access layer as layer 3, so we don't need protocols such as VTP. GLBP, the protocols such as like GLBP, like not a lot of people were using GLBP anyway, so they have removed the GLBP topic as well. So GLBP is no longer part of our content. So they removed those things which are like rarely being used in the production environment, the technologies that might have gone obsolete, or the technologies that might have been added into the other tracks. So based on that, like they do these removal and additions. Right, so you should keep an eye on this page to find out the changes that that are expected. You can assume like less than 20% change every year, which is also not guaranteed. They might try to, since like just to give you the information, currently at the moment, since they have announced these changes, no one has attempted the lab. No one from the enterprise infrastructure track, no one has attempted the lab since like 20th September. Today is like 4th December. And if no one has attempted the lab, how are they supposed to do the changes in the upcoming schedule? So it's not guaranteed that it will change 100%. So since they have changed it, maybe like for next 1 or 2 years, the content will remain as it is. But you can always expect the changes here and there. Less than 20%, however, changes you can expect. But still, you should keep an eye on this portal from where you can find out the changes. And you can click on this release notes. You can click on the exam topics that will show you the same page here. The exam topic, same page actually, same page you will be redirected to. Then here is like the software and hardware version. Here the list of the equipment and software. So this equipment and software list right here, equipment and software list. This is to let you know like what version you should practice on. So DNS Center, for example, release 2.3, SD-WAN 20.9. Everyone is going for 20.12, 20.12, but in the exam it is 20.9 anyway. iOS switching on 15.2, routing on 15.8. If you have like SD-WAN routers, then 17.9. So these are like the specifications of the software that we should have. Even if you have practice on any version of 15.4, 15.5, it's okay. The topics that we need to cover, they run exactly the same as 15.4, 5, 6, 7, 8. So it's not specifically that you have to go for 15.8. It just need to be iOS 15, not iOS 12. Right, so 15.8, 15.7, 6, 5, 4, everything will work, just not the 12, not the iOS 12. Right, so this is from the software requirement point of view. Right, if you have physical switches, it must run on Catalyst 9300 series switches running on the software version 17.9, ICE 3.1, Linux machine. So this is from the lab exam software and hardware point of view. So all the topologies that I have built, these are on iOS 15. All the topologies that you will get on the GNS, they will be on iOS 15. SD-WAN, we will cover on 20.12. In the exam, it is 20.9. DNS Center, we have 2.3. So this is like from the software and hardware point of view. Then the Excel sheet that you are talking about, it is right here. In CCIE Enterprise Infrastructure, version 1.1, learning matrix. You can click on that and you can download this Excel sheet. This is the learning matrix. This is you can download. This is the exact same thing. This is the exact same thing. So this Excel sheet that we have here, you can download this Excel sheet. It is going to list each and every topic that you should go through from the content point of view. Everything that you should go through from the content point of view, and of course from where you should cover it. So it also has this. These links from where like you should cover like these topics. There are several links that you can cover like these topics from. So you can refer to this one, and as our content progresses, on regular basis, an Excel sheet will be shared with you where we will update, like where I will update, like, okay, what topic we have covered on regular basis. So the final list will show you the exact same file, this one. Because if I download it and share with you, the formatting and everything will, be disrupted. So this thing will be shared on regular basis as our content progresses. Meanwhile, you can download this Excel sheet from here, and on regular basis you can update it, like, okay, what topic you have covered and from where you have to cover, all those things are mentioned here as well. So this is, you can download, right? Everything, like you click on this link, it will open a documentation. From here you can refer to the actually configuration examples and all. So they have given all the necessary documents, like here, everything. They have given all the necessary documents. Here you can just, the link that I have shared with you, just go through the very bottom of that page. And here you can click on this learning matrix or the software equipment list or the topics and release notes. You can get that from. So this is like about the changes. You can expect the changes, but not a lot. They might not even do the changes actually. But you should keep an eye on this portal, this page, to find out like if any changes are there. Now coming to the documents, there is no official book for CCIE Enterprise Infrastructure. For the CCIE Enterprise Infrastructure, there is no official book from Cisco. So they don't have any official enterprise infrastructure book that they have from Cisco. There is one from Narvik, but that is like lab. That is more like a lab book. It doesn't cover anything in theory. It's just pure labs. So that Narvik book is that we have CCIE Enterprise Infrastructure Foundation. That book is just pure lab. There is no theory in that lab. So if you want to cover the theory, you have to rely on the official documentation from Cisco, or you have to rely on the old books that you have. You have to rely on NCore book that you have. You have to rely on NRC book that you have. You have to rely on sd-wan book. You have to rely on SDA book that you have. There is no CCIE Enterprise Infrastructure official certification guide. So just like we don't have any official certification guide for switching nowadays. So these are the documents that you have to refer it. And of course, these documents will be shared with you. So these are all the necessary documents that you have to go through. So we have the old CCIE version 5, volume 1 and volume 2. So this old CCIE Enterprise Infrastructure, old CCIE Routing and Switching version 5, it is going to cover things such as switching. It is going to cover basic IP addressing, services such as, for example, HSRP, VRRP, GLBP, SNMP, syslog, those things. Then IGP routing, we have like RIP, no need to worry about it. EIGRP, OSPF, no need to worry about ISIS. Earlier we used to have ISIS as well. So only EIGRP, OSPF and static routing. You don't need to go through this entire book, only the topics that is relevant from the current exam point of view. So this is one of the old books that you have to refer to. Of course, this book will be shared with you. So this CCIE Routing and Switching in the PDF format. So this CCIE Routing and Switching version 5, volume 1, which focuses on the IGP routing. Then CCIE Enterprise Infrastructure, then CCIE Routing and Switching volume 2, which focuses actually on the BGP, quality of service and multicast. WAN we no longer have in our content. WAN, SDLC, PPP, those things we don't have. VPLS, Metro Ethernet, no longer there in our content. So BGP, quality of service and multicast can be covered from here. When it comes to security, they have like tunneling technology such as DMVPN, IPsec, GRE that you can cover from here as well. So these are the two books that you have to refer to. Routing and Switching version 5, volume 1, volume 2. Then if you want to cover things in, again, very much detail, just in case, if you want to, go through the content, if you want to cover a topic in very much detail, then TCP/IP, routing TCP/IP volume 1 and volume 2. Routing TCP/IP volume 1 and volume 2. This is like the very old book, but still relevant. Jeff Doyle. This is like routing basics. No need to go for this TCP/IP, all those things. But just in case if you want to, then you can go for it. We'll not talk about like this. Of course, we'll not talk about each and everything. So, for example, static routing. They have covered static routing, then the dynamic routing protocol, then the RIP, then IGRP. No need to worry about RIP. No need to worry about IGRP. Then we have RIP version 2. No need to worry about it. So EIGRP you can cover in very much detail from here. Then you can cover OSPF from here. These two topics you can cover from here. Right. Then we have this thing called volume 2. In the volume 2, they have this BGP, border gateway protocol. So 1, 2, 3, 4, 5, 6 chapter of BGP. Second book is purely focused on BGP and multicasting. So 6 chapter of BGP. You want to go through it, you can go through it. Then multicast routing, 1, 2, 3 chapter of the multicast routing. And then a few chapter of IPv6. We don't need to worry about NAT 64, NAT 44. We have like NAT in here. NAT, normal NAT. V4 to V4, public to private. So that is NAT 44. And NAT 64 means 6 to 4 translation. No need to worry about it. But the second book focuses on like BGP and multicast routing. So again, if you want to cover the things in very much detail, then you can go through this one. None of these books cover topics such as MPLS. So if you talk about MPLS, here is the MPLS. This is like one book that you can go for, that you can read from the MPLS point of view. Again, we will not cover each and everything from this book because this is more of the service provider book. So we'll just talk about like what is MPLS, what is label and all that. We'll talk about that from the book. But again, this is just if you want to go through in more detail. If you think that the topics that we have covered in the content is not sufficient from your production point of view and you want to know the things in more detail, definitely you can go for these books. So this is like MPLS, multi-protocol label switching. This is MPLS book. Then we have, if you want to study about quality of service, then this is a quality of service. This is a QoS. Earlier we used to have a certification for quality of service. So this is that old quality of service book. And in chapter by chapter, they have covered topics such as polishing, shaping, congestion management. So we have only like 2% quality of service, which we will cover from this book as much as we can. So this is like from where you can cover the quality of service. Then for the VPNs, we have this iOS VPN book. So this is like one book that we can go for, like for the iOS VPN point of view. Like the VPNs that we can configure, these things you can go for like from the iOS VPN point of view, like what is IPsec, what is site-to-site VPN, DM VPN. Again, this book covers things such as SSL VPN, Get VPN, which is no longer part of our content. So of course we will not talk about it. But again, if you want to know things in detail, you can refer to this book for these variety of labs and theory part. So VPN you can cover from here. Right. So this is the one, this is the NARBIC book. This is like CCIE Enterprise Infrastructure Foundation. Let's open the OSPF topic. So in the OSPF topic, we don't have any theory. It's just lab, just pure lab. There's no theory in this. This is the lab book. This is not a theory book. So this book will be of no use because it doesn't has any, it is just the lab part. It is not the theory. Right. So from the topology point of view, if you want to like go through it, you can go through it, but this is not the theory part. So this book is the official book from the Cisco for the CCIE Enterprise Infrastructure, but it is just the lab. It is not the theory. And of course, you have the ENCORE book. So ENCORE, the Enterprise Core book. This ENCORE book you can also refer to for things such as your packet forwarding, layer 2 switching, all the things that you should know from the switching point of view. This is more relevant to your current curriculum. Then we have things such as like routing. In the routing, we have EIGRP, 1 chapter of EIGRP, 2 chapter of OSPF, 1 chapter for OSPF version 3, then 2 chapter of like BGP. There is no MPLS in here, just the multicasting. So like you can refer to this Encore book as well for the written and of course the lab exam content. Right, quality of service, IP services, the tunnels, overlay tunnels, GRE, VXLAN, Lisp and all. So you can refer to this book as well. So we have a variety of documents, we have a variety of books, and all these will be shared with you. You can refer to these books on regular basis. As our content progresses, you can refer to these books, and these books you can use to cover the topics in more detail. However, like whatever topics we will do in the class, whatever things we will cover in the class, even if you watch those recordings a few times and then you refer to these books, it will be much more better. But these things like these topics can be referred to, like all these topics that we have in a content can be referred to from these official books. So not just one book, but we have to use multiple books to cover our entire content.
Sir,
Yeah.
so like we will receive all these books.
Yeah,
We'll
yeah,
have
yeah.
access to these books, and as
Yeah.
well as like for the recordings. Do we have access for the recordings
Yes, yes,
like
yes,
for
of
the
course.
whole time, or just there is a limited time?
No, no. As per what I know, you will have the recording. You will have the access to the recording throughout the content, like for the next 3-4 months, and then after that, I guess like you have the access for the recording for another 3-4 months. So 6 to 8 months, I guess you have the access for the recording. And if your recording gets expired, you can drop a message to Mr. Sugandh or Saurabh or whoever you are in contact with, and they will renew from their side the access to the recording.
Okay, thank you.
All right, so you will have the access to the recordings as well as all these documents you can download with, and you can keep these documents with you. Recordings, however, you will not be able to download. Of course, you can watch it on the you will be able to download, but only in the app, as I'm aware. So you can download and refer to the recordings, but you will not be able to download or export the recording onto your local machine.
Okay.
And one more thing, as you said, like the recording duration will be for 6 to 8 months. Now, what if our course content is for 6 to 8 months? So recording will be according to that only. And if we want to renew it, so do we need to pay anything?
That thing needs to be discussed. I don't think you have to pay anything. Just you need to drop an email that your access to the recordings has expired. But you do need to confirm it from the management side, like Mr. Sugandh, Saurabh, or whoever is in contact with you. Like, so you can drop them a message and they will let you know about the recording scenario. That you will not be able to download these recordings, but you will have the access to these recordings on the portal itself. So you will have the access throughout the content until our content is done. You will have the access to those recordings plus additional 3-4 months you will have the access to the recordings. And then after if the recording access expires, then you can drop them an email, a message, and then they can renew it from their side. About the payments and all, you need to confirm it from Mr. Sugandh or Saurabh. As I know, I don't think there is any payment for the same.
And what about the lab part? The lab topology you're going to share?
Lab
Will it
topology, you
allow?
can download and you can have it with you anytime you want to do the things from the scratch again. You can just wipe the notes. It will reset the lab to the default configurations and you can start again. So lab, I will give you for the download access. Yeah, I will come to the prerequisite just
I'll just like to add on the point that one of our colleagues was mentioning. So in terms of the access to the recording, let's say I've done the sd-wan like in June, July, August, and it expired. So I have requested for the further access to the lab, and Mr. Saurav has provided. So that's not an issue at all. So just wanted to
no extra payments, right?
Yeah. No.
Okay. So that answers your question. So you can just drop them a message and then you will get the access to the recordings. Now, you might already have guessed that this is not going to be a beginner level of classes. So there are a few prerequisites that you should know, and those prerequisites are like you should have basic understanding of routing. Since we will talk about the routing, you should have like basic understanding of routing, such as like what is routing, why we use routing, what is like IP addressing, what is subnetting, what is class A IP, what is class B IP. Just the basics like you should have, like your basic concept should be clear. Recommended to have like CCNA training, recommended that you have the CCNA training, and of course the NRC. ENARSI, which is like this one. Let me quickly show you. Again, recommended, not mandatory, but this one. So if I show you this NRC training, you will see that this is purely routing. So it's recommended that if you have this training, it's good. It will be good that you will know few things like in advance, so that you can put up more questions actually. So recommended to have like CCNA and this NRC training, ENARSI, advanced like routing, switching infrastructure. But even if you don't have, it's not a hard and fast rule that you have to go through these trainings, because what happens like in the CCNA, we cover our basics of like routing, subnetting and all those things. And in this NRC training, actually, we cover the basic of routing, pure routing, VPN, infrastructure, security and services. So in the routing, we cover like at a very moderate level, things about EIGRP, things about OSPF, things about BGP, things about like VPN, GRE, DMVPN. So if you have this training with you, if you have already covered this like content, it will be easy for you to understand the topics, the things that we will cover, and you will be able to put like more questions. But it's not a hard and fast rule. Even if you have just the basic understanding of the routing, what is a router, what is a switch, what is class A, class B, class C addresses, what is TCP IP, basic CCNA, like if you have CCNA level of understanding, then also it will be okay. So the only prerequisite for the content for the entire thing that we will talk about is that you have your basic CCNA, like CCNA knowledge, CCNA level of knowledge is required. Plus, if you have done the NRC, Enterprise Routing and Switching Infrastructure, that NRC training if you have done, which covers things in detail about like IGP and EGP protocol, it will be okay. Because topics such as, for example, like IPv6, topics such as like MPLS, multicast routing, quality of service, these are not covered in even NRC. So like if you have, even if you have completed the NRC, you will have the understanding of OSPF, EIGRP, BGP, that too in a moderate level. So you will be able to put more questions. So if you have that training with you, it's okay. Otherwise, it's not a mandatory thing that you have to have. Just you should have basic understanding of the routing, what is routing, how the routing happens, basically CCNA. Your CCNA level concepts should be clear. Now in CCNA, we have like routing, we have switching, we have like netting, we have VLAN, VTP, all those things are there. So if you have like your CCNA understanding, if you have CCNA level of understanding, the content, you will be able to easily cover the content. Even though we will start the things from the scratch, just to let you know. For example, like when we start the EIGRP, we'll talk about like the EIGRP from the scratch. When we talk about OSPF, we'll talk about the OSPF from the scratch. But of course, I will not tell you like the history of OSPF, the history of EIGRP. I will assume that you know EIGRP is a routing protocol. I will assume that you know that OSPF is a routing protocol. I will assume that you know what is routing, what is addressing, what is IP address, what is /30, /29, what is a subnet. Those things I would assume that you know. I will not assume that you know a lot about BGP. I will not assume that you know a lot about VPN, multicast, but just whatever things we have in our CCNA, I will assume that you know about those things. So that is the only prerequisite that we have. And of course, we will cover everything from the slides on regular basis. This is the slide that we will be referring to. And you will get the access to these slides on the portal itself. So you can refer to these slides on the regular basis. So this is the things that we have talked about today. So enterprise infrastructure. So same thing that we have talked about today. So 30% for the infrastructure security, then SDN, then transport technology, then services, automation programming, then like the content, although there is no prerequisite for the course, but should be familiar with the basic technological concepts such as switch management, EIGRP, OSPF, BGP, and some other. Recommended to have CCNA and NRC plus ENCODE training for the detailed discussion of the topics for CCIE EI. Throughout the content, it will be assumed that you have at least basic to intermediate level of understanding of the topics. The topics that usually are covered in the lower level in CCNA and CCNP, topics such as routing, topics such as IP addressing, topics such as subnetting, those things will be assumed that you already know. Of course, if you have questions, you can ask it. It's not like you cannot ask the questions from the basics, but it should not be like what is a class A address, like it should not be what is a class B address. That things you should be already familiar with. right? So on regular basis, you will know what topics we are going to cover. So you can like go through the CCNA or CCNP books, topics, videos, and then you can, come to the next class and then you can put up the questions and also just the basics of CCNA. And if you have the CCNP level of training, it will be an added advantage. Basic, I will assume that you already know. I will assume that you already know basics of routing, basics of rest we will cover from the scratch. Like for example, when we talk about routing, we will complete the routing. We'll talk about the routing from the scratch. We will do the packet captures. We will do like Wireshark packet captures and all those things. We'll do from the scratch. But of course, like I will assume a certain, like for example, I will assume that you know what is a routing table. I will assume that you have seen the routing table before. You know what is this directly connected route is, what is this static route, what is this EIGRP route is. I will assume that you know at least these basic things, right? So that will be the prerequisite. Omkar, I will share the link to that. That is the same group for the switching and routing. I have the same WhatsApp group. So as soon as like after a few days, 1 or 2 days, I will share the link and everyone you can also join that group. Right. So that's I guess all that we have to talk about from the content point of view, how we are going to content, how the labs are going to be covered. If still like you guys have any questions, you can ask. This you can download from the website, and the one that will get updated on regular basis, this one you will get like by tomorrow. So once we have done a few topics, you will get the access to this kind of an Excel sheet where you can track on regular basis what topics we are doing. Any more questions, anyone, from the content, what we are going to cover and all that? If you guys have any questions, just let me know. Any doubts so far? Just to again brief you, repeat the labs that we do on regular basis. In the technology classes, whatever labs we are doing, just once the class ends, refer to the recordings and repeat the lab as it is. Try to understand what concepts we have covered in the classes and repeat the lab as it is. So that once when we discuss like, okay, these kind of questions are asked in the exam, you know the solutions of those questions. You don't have to do it, but you know what is the solution to those questions. From the lab exam point of view, the CCIE lab exam that we have, it is like of two things. We have two sections to complete. We have two modules to complete in our CCIE lab exam. One is like the design module, and then second one is deploy, optimize, and operate. So design module and deploy, optimize. First you design, then deploy, optimize, and operate. The design module that we have, it is 3 hours in total, and the deploy, optimize, and operate module, it is 5 hours in total. You can't borrow the time also, so it will be a fixed 3 hours, it will be a fixed 5 hours. Earlier we used to have 3 things. So let me write. So in the CCIE lab exam that we have, so we have like a design module, and then we have like the deploy, optimize, and operate. Design is 3 hours, and the deploy, optimize, and operate is 5 hours in total. We can't borrow the time. Earlier we used to have like T-shoot in the old content, then we had the DAG, and then we have the configuration part. So earlier also it was 8 hours, nowadays also it's 8 hours, but nowadays we don't have any T-shoot. DAG is what we know as the design nowadays. Like earlier we used to have this 30 minutes. This was like 30 minutes, this was like 2 hours, and this was like 5:30. We can borrow the time, like 30 minutes we can borrow from here to there, but this was like the old like pattern. Nowadays, like this T-shoot is no longer part of our this exam, and we have like DAG and we have the config. So DAG is what they refer to as nowadays design. So in the design, they have in the design section, which is 3 hours, it is like MCQ. It is like multiple choice questions. There are total 38 to 40 questions in the design part. You do not have access to any device. You don't have access to any device. It's just it's like your production environment where you have received an email from one of your client. You will go through that email. You will go through that mail thread, and you after that mail they have asked the question. The client has asked the question. You will read that question, and based on the resources, you will try to provide the best solution among of these like one of these like 4 solutions. So this is what is expected in the design. Then we will have some drag and drops But mostly it is MCQ. Mostly it is multiple choice question. 3 hours you get 38 to 40 questions MCQ you are going to get. Throughout the design module, your topology will keep expanding. Like you will notice that in the first 1 or 2 questions of the design module, the topology will be very limited. And then they will add the SDA branch, then they will add the sd-wan branch, then they will add a few more branches. The design, then they will include the automation programming. So throughout the design, throughout the design module, you will notice that the topology of the client will keep increasing. And the final topology that we get after the last question is what we have to work on. In the configuration, in the deploy, optimize, and operate module, you will work on the same topology that you get after the design. So it's like you are suggesting variety of things to your client, and the client has added those things in the design, and now it is asking you to deploy, optimize, and operate their network. So the topology, the final topology that you will get at the end of your design will be the topology that you will be working on in your section number 2. This is going to be a pure 5 hours configuration classes. Here we have approximately 25 questions total. Approximately 20 to 25 questions we have that you need to actually answer, and based on how you have performed in the design and how you have performed in the deploy, optimize, and operate, the overall you have to clear design, you have to clear the design optimize, you have to clear the do, you have to clear the design, and then you have to clear overall. Then you will clear the lab exam. There is no like how much amount of marks you should get to clear the exam. We assume that it is 80 to 85%.
I just want to ask one thing. Like, do you provide the same replica practice session for this lab part?
No. We will not be using the same thing exactly, but you can say that the topologies that we'll be working on, it's not the same as, but the questions that they have asked in the exam, very much we will cover all those questions throughout our training. But the topology, no, we cannot, of course, like we cannot discuss the questions and topology as a part of our content. It's not, basically it's a violation of their NDA. So like not in our theory classes. Routing, as you might already know, routing basically is a process of forwarding the packets from one network to another network. And by one network, I mean like one subnet, one range of IPs from the another range of IPs. So let's say there are 2 devices. One device has the IP address of 10.1.1.1/24, and another device has the IP address of 10.1.2.1/24. If this PC wants to communicate with this PC, since these 2 PCs are in 2 different network, we can find that out by taking a look at the IP address that we have configured on here. And of course, like as we have already covered, as we have already discussed in the previous classes, like I said, you should know what is a network, what is a subnet, what is an IP address. So those things you should be familiar with, right? So if I perform subnetting as per this given IP address and subnet mask, I can find out that my range, I belong to a network that has an IP range of 10.1.1.0 to 10.1.1.255. And if I perform subnetting, if I try to expand, if I try to write down the range of the IP to which I belong to, the range of the IP is going to be 10.1.2.0 to 10.1.2.255. So this is the IP address, this is the IP address from this range, and this is the IP address from this range. So this IP belongs to this range, this IP belongs to this range. Normally we say that this IP belongs to this network. The first IP of every range is what we refer to as the network ID. The first IP of every range is referred to as the network ID. So we say that this IP belongs to this network and this IP belongs to this network, just the basics. So if I want to go from like one device to another device, this device is going to see, this device, this sender device, this sender is going to see that I want to reach to this destination, and this destination IP does not come in my range. This destination IP does not belong to my own network. This destination IP does not belong to my own range. That means I cannot reach there. If the destination is not in my own subnet, that means I cannot reach there directly. I need to go towards a device which is responsible to forward the packet from one network to another network. Similar to that, when this device tries to send any traffic, this PC, which has the IP address of 10.1.2.1, when it tries to send any traffic to 10.1.1.1, this PC is also going to see that if I want to reach to 10.1.1.1, this 10.1.1.1 does not belong to my range. In order to go to 10.1.1.1, I need to forward the traffic towards a device which is responsible to forward the traffic between two different networks. So for that, like, this device is going to generate the packet, send it towards the device which is responsible to forward the packet in between two networks, which is in our case typically going to be a router. Similar to that, this device is going to generate the packet and send it towards a device which is responsible to send the packet towards a different network, which is again going to be a router. So router is the device which receives the packet from one network like 10.1.1.1 going towards like 10.1.2.1. Router is the device which is going to take a look at the destination IP and decide how to forward that packet from one network to another network. And that process of forwarding the packet from one network to another network is what we refer to as the routing. So routing basically is a process of forwarding the packet from one network to another network. This packet forwarding, this method of packet forwarding, which we refer to as the routing, can be done by any device which is capable of performing the same thing. Not only by the router, we can have devices such as, for example, layer 3 switches. We have the devices such as, for example, firewall. We have a variety of other devices that can perform this task, not just the router. Routers are more commonly used for this purpose, but apart from like router, we can also use devices such as layer 3 switches. We can also use the devices such as a firewall. So routing is a process of forwarding the packets from one network to another network, and whatever devices can forward the packets from one network to another network, these devices are known as routing capable devices. And typically, since we are forwarding the packet based on destination IP, based on the destination IP, we are forwarding the packets from one network to another network, and IP address works as the layer 3 of the OSI model, or the IP address works as the layer 3 of the TCP IP model. That's why we typically say that routing is a layer 3 function. It is the responsibility of the layer 3 of the OSI or TCP IP model to perform the routing. So any device that is capable of performing the routing can be said a device that works at the layer 3. So layer 3 devices are those devices that take their forwarding decision based on layer 3 address, which is an IP address. In short, whatever devices can forward the packet based on the layer 3 address are known as the layer 3 devices, and most commonly utilized layer 3 device is going to be a router. It is going to be a layer 3 switch. So typically, to perform the routing, we use a router or we use a layer 3 switch. Other devices such as firewalls can also be used to perform the routing. Right. So in brief, routing is forwarding packets based on layer 3 address. Forwarding of the packets based on the layer 3 address is known as the routing or layer 3 forwarding. And devices that can switch the packet on the basis of the layer 3 address are known as layer 3 devices. Example is going to be router or a layer 3 switch. We can also have devices such as firewall performing the same function. So routing is a process of forwarding the packets from one network to another network, from one interface to another interface based on the layer 3 address. And whatever device can forward that packet from one interface to other interface, from one network to another network based on the layer 3 address is what we know as the layer 3 device. And typically, router and layer 3 switches are considered as the layer 3 devices. We have other devices as well, but a router and a layer 3 switch, these are like two commonly utilized routing capable devices. Now remember that these devices like router and layer 3 switches, these always forward the packet based on the destination IP. The only thing that they care about is the destination IP. When the router receives a packet, the router is not going to take a look at the source IP. Destination based forwarding, the router is going to take a look at the destination IP, and based on the destination IP, it will perform the packet forwarding. As opposed to a switch, if we have a layer 2 switch, a device that forwards the packets based on the layer 2 address, which is the MAC address. If we have a layer 2 switch not only checks the destination MAC address, but layer 2 switches also take a look at the source MAC address. They learn the source MAC address, they install that source MAC address in the MAC address table, and then they take a look at the destination MAC address, and then they decide how to forward the packet, how to forward the frames from one interface to another interface. So that is also a fundamental difference between a router and a switch. That switch is going to learn both source and destination information. Switch is going to learn the source MAC address, then install that in the MAC address table, and then based on the destination MAC address, switch will decide how to forward that frame from one interface to other interface. However, the router only considers the destination IP in its packet forwarding decision. When the router receives a packet, the router is going to take a look at the destination IP, and based on that destination IP, it will decide if the packet has to go from one interface to other interface, or if the packet has to go from the one interface to the other interface. Basically, source-based routing, ideally the routers, they perform destination-based forwarding, destination-based routing. They do not perform source-based routing. However, source-based routing can also be done by the router, but for that we need to enable some additional command. Routers can also perform, these devices, these layer 3 devices can also perform the packet forwarding based on the source IP, but typically these devices perform the packet forwarding based on the destination IP address. An example of your source-based routing. An example of your source-based routing is going to be policy-based routing, PBR, where when we apply the policy-based routing on the router interface, router is going to check the packet against the rules that we have defined in that PBR. It is going to take a look at the source IP, it is going to take a look at the destination IP, and based on both, it will decide how to forward the packet from one interface to other interface. So routers can perform source-based routing, but typically you will notice that the router will perform, or these layer 3 devices will perform the packet forwarding based on the destination IP address. Source-based routing, example of the source-based routing is going to be your policy-based routing, where we apply a route map, where we apply a basic rule to decide, to tell the router how the packet forwarding has to be done based on these predefined rules. So we don't need to focus on the policy-based routing at the moment. The only routing that we need to focus on is a basic destination-based packet. Now, when the router receives a packet, the packet has the source IP of 10.1.1.1 and the destination IP of 10.1.2.1. This is the source IP of the packet, and this is the destination IP of the packet. When the router receives a packet on one of its interface, and now the router has to decide how to forward that packet, the router is going to take a look at the destination IP 10.1.2.1, and it is going to check, do I have a route to reach to that destination or not. Routers, they maintain these devices, these layer 3 devices such as router, they maintain a table. That table is typically referred to as the routing table, where they keep an information on how to forward a packet. So if I receive a packet that is going towards the destination 10.1.2.1, how that packet has to be forwarded, that information is going to be maintained in a table known as the routing table, also known as the routing information base or RIB. So routing table or RIB, routing table or routing information base, RIB, is a table that is maintained by these layer 3 devices where routes information is there. So all these layer 3 devices, they maintain a routing table so that they can maintain the destination network information. So the destination network information, like how can I reach to that destination, that information is maintained in a table, and that table is known as the routing table. This is how a typical routing table looks like. This is an example of the routing table. This is how a routing table looks like. We can check the routing table by the command show IP route. This is how a typical routing table looks like. These are the codes. Codes represent like how these routes have been learned. L stands for local, connected, static, and so on. Here we have, if we have configured a default route, then that information will be shown here. Gateway of last resort is 10.0.4.2 to the network 00. Means like if you have to go to any destination that is not available in your routing table, you can go to this next hop, you can go to this gateway. If you don't have a route to reach to any destination in the routing table, you need to go to this gateway. That's what we refer to as the default gateway. That's what we refer to as the default route. So if you have configured a default route, then that default route information is also referred to as the gateway of last resort. This is going to be the next hop, and this is going to be the network 0000. Means like to reach to any destination that is not available in your routing table, you have to go to this particular next hop. It's also maintained here, by the way, it's also maintained here. So you can take a look at this, or you can take a look at this. It is going to give the same information that if you want to go to any destination that is not present in your routing table, you have to go to this gateway, you have to go to this next hop. And the same information is actually maintained in here as well. So this is also a default route, and the default route information can also be seen with the name of gateway of last resort. Alongside that, we have directly connected network. L stands for local. So whatever IP I have configured on the interface, that IP address that I have configured onto that interface will be shown in the routing table with the keyword L. L stands for local. It is only in the iOS 15s that you will see this entry. In iOS 12, you do not see this entry L1. L stands for local. So whatever like IP address I have configured on that interface, that exact IP address will be shown here. And in general, what subnet is connected onto this interface, that subnet information is going to be shown here. Then we have like routes learned via protocols such as EIGRP. D stands for dual. Dual is the algorithm for EIGRP. So D stands for dual, S stands for static, O stands for OSPF. So this is how the routes are maintained in the routing table. Routes are maintained along with like how we know about that route, along with the subnet, mask, AD value, metric value, next hop, exit interface. These are like the components of the routing table. In the routing table, we have routes, how those routes are learned, what route actually, what subnet, the AD value, the metric value, next hop, exit interface, all that information basically is maintained in this routing table. This is a sample routing table. This is how a routing table basically. Now, when the router receives a packet, let's say the router has received a packet to go to, let's say, for example, 11.40.96.27. This router has received a packet, and that packet has to go to the destination 11.40.96.27. The only thing that the router cares about, that if I have received a packet onto this interface, what is the exit interface? The only thing that this router cares about is the exit interface. Once the packet is received onto this interface, packet got decapsulated, the router is going to take a look at the destination IP, and then the router is going to find out if I need to go to that destination, what is my exit interface? Like out of these multiple interfaces, on which interface should I place the packet so that the packet can reach to the destination? A router is not responsible to actually send the packet towards the destination. Router has no guarantee. Router basically takes no guarantee that the packet will 100% be delivered onto the destination. The only thing this router is going to do is once it receives a packet on one of the interface, it is going to place that packet onto the other interface. Once the router places the packet onto this interface, that's it. Its responsibility is done. This router doesn't really care if the packet gets delivered or if the packet does not get delivered. The only thing that this router is going to do is to take the packet that is coming on one interface and place it onto the other interface. So it is going to take a look at the routing table only and only to find out what is my exit interface. If I need to go to this 11.40.96.27, I have multiple routes in my routing table. What route, what exit interface I have to use. And once this router checks the routing table, it finds out that in order to go to 11.40.96.27 subnet, I need to place the packet onto the interface gigabit 0 by 1 towards the next hop 10.0.4.2. It actually doesn't care about the next hop. The only thing that it cares about is the exit interface. Once it finds the exit interface, it will place the packet onto that particular exit interface. Now, once the packet is placed onto this exit interface and the packet is forwarded out of that interface, a router doesn't really care if the packet is delivered onto the destination or not. It is the responsibility of your sender. It is the responsibility of your sender to somehow ensure if the packet is delivered onto the destination or not. It is not the responsibility of the router to perform reliable delivery of the packet. A router is just going to take a look at the destination IP, and based on that destination IP, a router is going to forward the packet from one interface to the other interface by referring to the entries in the routing table, and that is it. Once the router places the packet onto the exit interface, that's it. The router is not going to do any acknowledgement thing, or it is basically not responsible to make sure if the packet gets delivered onto the destination or not. It doesn't actually also care about this next hop. However, this next hop will be used, but it really doesn't care. Even if I don't give the next hop IP, even if only and only exit interface is there, then also the router will place the packet from one interface to other interface. The only thing that it cares about is the exit interface. It does not care about this routing table, the entries in the routing table that the router has. It doesn't care about this next hop IP. However, it is required, but it doesn't care about this next hop IP. The only thing that it cares about is the exit interface. Once it finds the exit interface, that's it. Once the router finds the exit interface, that is it. Once the router has found out that this is the exit interface to reach out to the destination, that is it. Router will take that entry, router will refer to that entry, and then router will perform the packet forwarding from one interface to the other. So layer 3 devices maintain a routing table to maintain the destination network information so that they know the exit interface to reach to the destination. And to know the exit interface, they look up the routing table. So once a layer 3 device, such as a router or a layer 3 switch, once it receives a packet, it has to forward that packet based on the destination IP. It is going to take a look at the routing table. In the routing table, it will look up, if I need to go to this destination, what is my exit interface? And then whatever is your exit interface, the packet will be placed onto that particular exit. Remember that when the packet is received onto the router, a process called decapsulation will happen. And when the packet is placed on the exit interface, then a process called encapsulation will happen, which will be discussed later on. So packet will be received, packet will be decapsulated so that the router can know the destination IP. Once it finds out the destination IP, once it takes a look at the routing table, once it finds out the exit interface, when the packet is going to be placed on that exit interface, then the packet has to be again encapsulated, and then the packet will be sent towards the next. Also note that when the router forwards the packet out of the exit interface, it's not like the packet will always go to the destination. There is also a chance that when the router forwards the packet went to the another router, then from there it went to the another router, then from there it went to the another router, and then from there it reached to the destination. So when the packet is received, packet is decapsulated. When the packet is sent, packet is encapsulated. Once the router forwards the packet out of a certain exit interface, it really doesn't care if the packet is received at the destination or if the packet is received by another router. If the packet is received by another router, then that router will perform the decapsulation. That router will take a look at the routing table. That router will find out the exit interface. That router will perform the encapsulation and forward the packet towards the next router. Decapsulation, encapsulation, decapsulation, encapsulation will happen from the source to the destination. So what I'm trying to say is that next hop of a packet can be a destination, or a next hop of the packet can be a router. Like when a packet is generated by the device, next hop of that packet can be a router, and from the router then the next hop can be the destination itself, or the next hop can be another router, then another router, then another router, and then another router, and maybe 10 then to the destination. Next hop means next stop. Next stop of the packet, next hop of the packet can be the destination, or next hop of the packet can be a router, right? So if we have multiple routers connected, for this router, this is the next hop. 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 For this router, this is the next hop, and next hop is the destination in our case. So next hop can be a router, or a next hop can be a simple next hop can be the destination itself. So these are the content of the routing table. In the routing table, we have the network ID, subnet mask, how the route is learned, AD, metric, next hop, exit interface. These are commonly seen entries in your routing table, which you can also refer to from here. This is a sample routing table where we have like we use the command show IP route to find out the routing table. So this is the default gateway information. This is the how we have learned the routes. This is the subnet information. Then this is the exit interface. This is the next hop. This is the AD. This is the metric. So we have all that kind of information in our routing. So routers, they do the packet forwarding based on the entries available in the routing table. Not only routers, all the layer 3 devices, they do the packet forwarding based on the entries in the routing table. Let me know any doubts if you guys have any questions, anyone so far. You can ask any, just the basics. Any questions if you guys have, let me know. So to see this routing process, what I'm going to do, I'm going to build this topology, this simple topology that we have. Yes, Amit.
Can I ask my question?
Yeah, let me know.
So as you said, sir, like the router does not maintain a session whether the packet has reached to the next hop or the destination. So is there any mechanism? I mean, we use TTL to understand whether the packet has reached. There's a communication through TTL. So how does it actually happens? I'm a bit confused here.
Let's understand that with a simple topology. Let's create a simple topology and let's see like when we do the ping, what exactly is the process that happens, and then you will get much better idea. Right. So let's build the same topology that we see in the in this diagram, and then let's try to understand the process, and then hopefully like that will clear your question. So I'm going to build the same topology like this thing. I'm going to build on GNS. So I will use, as per the topology, I'm going to use two routers here. So this is the GNS. I already have like two routers set up. One is like on iOS 12, one is on iOS 15. I'm going to use a basic iOS 12 router here. I can also use iOS 15 router, completely up to you. So this is going to be router number 1. This is going to be the router number 2 as per the topology. And as per the topology, I'm going to connect them with the help of a serial cable, which I don't have here. So I'm going to connect router 1 and router 2 with the help of the serial cable as per the diagram here. Although it is very less typical that you see these serial cables nowadays, but since in this diagram it is mentioned the serial cable, so let me right click on this router. Let me go to configure. I will go to the slots, and from there I can add one serial slot. I guess WIC is not available here. So let me see if I have this one, maybe. Let's see. Configure slots and 4T. Let's see. So as per the topology, I have connected like these two routers with the help of a serial cable. Numbers can be anything. You don't need to worry about the numbers. Don't need to match the numbers exactly the same as per the topology, right? So here, these are two routers. Then I'm going to connect them with a switch. Remember that in this GNS software, switch actually has no use. It is just a normal Ethernet switch. We cannot run any commands or anything like that. And we don't need to worry about the switches here. So just using these switches, it is FA 0/0 and it is also FA 0/0. Then I can either connect a PC from here. I can connect a VPCS on here, but I'm not going to do that. Additionally, I'm going to use like the same two routers here, and I'm going to make these two routers work as the PC and the server as represented in the diagram. So this is going to be a PC and this is going to be a server. Basically, these are the routers, but I will configure them as a PC and I will configure one of them as the server. So I will just I have just changed the name. I'm going to change the symbol so that this doesn't get any confusing. So computer, and I'm going to change the symbol of this device as well to a server. So, and then I'm going to connect these PC with this switch. And connect this PC. Connect this server with the switch. Remember that this is just a router which I'm going to configure as the PC. It's not actually a real PC. It's not actually a real server. It's just a router which I'm going to treat as the PC and server respectively. So this is a sample topology that we have to build as per the diagram. You can confirm it. Same thing. So we have two, for example, here routers connected via serial cable. Then we have PC switch. Switch has no use here. Switch is just to connect like the PC with the server, a PC with the router, and here just server with the router. So switch has no use. Switch has no use. It is on the default configuration. It is on the default configuration. So we don't need to worry about switching. Okay. So now let me configure the IP address here. So power on all the devices. And now since we are talking about these things from the scratch, let's discuss a few more things like, so on this PC, First of all, I'm going to configure the IP address. On this server, I'm going to configure the IP address. So remember that this is just a router, which is more like acting as the PC. So first of all, I will go to this PC, which is in fact a router. So very first thing that I'm going to do here is to disable the routing capabilities. So configure terminal, no IP routing. This command is going to disable the routing onto that device, which means like this device is now just a end user device. It is no longer capable of performing the routing. So we can consider this device now as the end device. So no IP routing. Then the IP address that I'm going to set here, interface FA0/0, I'm going to do the no shut, and I'm going to set the IP address as per the diagram 192.168.1.2 to 55.255.255.0. As per the diagram, the IP address that I had to set is 192.168.1.2. You can also confirm it from here, 192.168.1.2. Now, before I hit enter here, let me do the packet capture. So once you install the GNS, tools such as, for example, Wireshark also gets installed here. So I'm just going to, either I can do like right click capture, or I can do right click capture. It's the same thing. Right click start capture. It will start the Wireshark software. Right. Now I'm going to do the no shut here. Right. So I'm going to go on the PC and I'm going to do the, I did the interface FA0/0. I did no shut, and then I am trying to configure the IP address onto that PC. Remember that on any device, when you configure the IP address, let it be like a PC, a switch, or any device where we configure the IP address, the very first thing that this device is going to do, this device is going to find out if this IP address is unique or not, because we should not have the same IP address in one broadcast domain. This is one broadcast domain. This is one local area network. This is one locality. In one broadcast domain, one IP address must be configured only on one device. So this is one LAN, one local area network. If I'm trying to configure the IP address 192.168.1.2 here, that IP address must be unique. If the same IP is configured on another device, a conflict might happen and your packet forwarding will not be done properly. So this device, before it configures the IP address onto the interface, this device is going to check if this IP is unique or not. And in order to check the uniqueness of this IP, in order to check if this IP is unique or not, remember that this is just the basics. In order to check that this IP that we are trying to configure on this PC, this server, this router, this switch, this firewall, in order to check if this IP is unique or not, this device is going to generate an ARP message, address resolution protocol, which is, hope you know, responsible to resolve IP to MAC. Like we know the IP address, but we don't know the MAC address. So to resolve the IP, to resolve the MAC address from the IP address, to resolve the MAC address from the IP address, to get the MAC address from the IP address, we use this protocol called ARP, address resolution protocol. This address resolution protocol can not only be used to resolve the MAC address from the IP address, but this address resolution protocol can also be used to check the duplicacy of the IP address. This ARP is also used to check the duplicacy of the IP address. So as soon as I hit enter here, I can observe that the device has sent an ARP message. Gratuitous ARP or GARP, basically we call this GARP, G-A-R-P, or gratuitous ARP we call that. It is basically an ARP reply. It is not an ARP request, it is basically an ARP reply. So what this device did, actually what this device did, this device generated an ARP message, which is what we refer to as GARP, GARP, or we refer to as the gratuitous ARP. That GARP message is generated, which is eventually it is just an ARP reply. If I open this ARP message, if I open this GARP message, if I open this message, this is just an ARP message. If I open this ARP message, I can see that this is an ARP reply. Where is that? Here. Ideally, what happens? A device sends the ARP request, then you send the ARP reply. But in case of GARP, in case of gratuitous ARP, in case of that GARP, which is used to check the duplicacy of the IP address, for instance, So this device is going to generate, as soon as I configured the IP address onto this device, the device is immediately going to generate a message called GARP or get it as ARP, which is just an ARP reply. In that message, hardware type is Ethernet, always will be 1. Protocol type IPv4, it will always be 0x800. Size, then sender MAC address, which is like your own MAC address. Sender IP means your own IP. Target IP 192.168.1.2 and target MAC address FF. Basically, this device has generated an ARP reply. In that ARP reply, it is letting everyone know that I have this IP address and I have this MAC address associated with this IP address. And this ARP is going to be broadcasted. As you can see, you will never say that this ARP is getting broadcasted from here. It is incorrect. Technically, it is incorrect. You will not say that this ARP packet is getting broadcasted. You will say that ARP packet is getting broadcasted by taking a look at the data link layer header. Here we have the destination MAC address as the broadcast MAC address. From here, I will say that this ARP message is getting broadcasted. So source MAC address, your own MAC address, and the destination MAC address is a broadcast MAC address, which means that this device, the ARP that it has generated, it is going to be broadcasted to everyone in this broadcast domain. And if any machine has the same IP address as 192.168.1.2, that machine is going to send an ARP message of its own, saying that I also have the same IP address and I have this XYZ MAC address, by which this device will come to know that I actually am trying to configure a duplicate IP, and you will get a message saying that duplicate IP detected. But since we do not have this IP configured anywhere else, when this ARP message was sent, I did not get any ARP reply. I did not get any ARP message in response that confirms that this IP is not available anywhere else. As a result, this device was able to configure this IP address onto the interface FA0/0. This is the very basic thing that happens. So ARP reply ideally is unicasted. Also keep in mind, ARP reply is ideally unicasted. ARP reply is unicasted. But in this situation, since it is gratuitous ARP, it is ARP reply, but it is not being unicasted, it is being broadcasted as confirmed by this packet capture. So remember, this is a special case of the GARP. This is a special variation of the ARP which is used to check the duplicacy of the IP address in the broadcast domain. Remember that in this GARP, sender MAC address is going to be your own MAC address. Sender IP is going to be your own IP. Target IP is again going to be your own IP because you are trying to check the duplicacy of the IP address, and target MAC address is going to be FFFFFF, broadcast MAC address. Basically, you are not trying to resolve a MAC address from the IP address. It's more like you are telling everyone that I have this IP address associated with this MAC address. So it's more of a ARP reply, not the ARP request. And since I did not get any response for this ARP, which proves that this IP address was actually unique, so I can configure that IP onto the device. Now, if I try to do the same on router number 1, if I go to router number 1 and just for the proof, configure terminal, I go on the interface FA0/0, I do the no shut, and here I configure the same IP address 192.168.1.2. If I try to configure the same IP address, this router number 1 is going to do the same task. This router number 1 is also going to generate an ARP message. That ARP message will again be broadcasted. That ARP message will be received by the PC1, and the PC1 is going to send an ARP message of its own, which is going to confirm that this IP is already being configured on the PC1, and as a result, you will get here a message of duplicate IP address. So the same process happened again. This time, as soon as I configured the IP address on the router number 1, the router number 1 sent an ARP message. In response, the other device sends the ARP message again. So these devices are continuously exchanging the ARP message, and you will get the duplicate address detected error onto the device again and again and again. So because do show IP interface brief, FA0 by 0, since this IP address is configured on 2 devices, you of course are going to get this message again and again saying that same IP is configured on 2 devices. How that happens? It happens based on these ARP replies, based on these gratuitous ARP, or known as the GARP. So if you get any these kind of messages onto the console, just understand that you have unknowingly, or you might have configured like same IP address on multiple devices, which you need to fix by changing it, something like that. So now when I correct the IP address, the device is going to again generate the ARP for 192.168.1.1, and since it is not available anywhere else, now safely that address can be used, and we will no longer get any duplicate IP messages onto the console. This is a very basic thing that happens when we configure the IP address. Doubts? Let me know. Any questions so far?
Hello.
Yes.
Yeah. So it is layer 2 or layer 3 means.
Now, okay. Now there is like a lot of I would say debates on ARP. Like, is it a layer 2 message or is it a layer 3 message? In my opinion, ARP is a layer 2 protocol. ARP is a layer 2 protocol. ARP is used to more like bind the IP address with the MAC address. ARP is used to resolve the MAC address, because you think about it, at the layer 3 we can use variety of like protocols. At the layer 1 we can use variety of media. So ARP is more like to bind layer 3. ARP is used to bind the layer 3 address with a layer 2 address. So but when we talk about from the messages point of view, I consider ARP as a layer 2 protocol. ARP messages are directly, however, some people say that ARP is a layer 3 protocol, some people say that ARP is a layer 2.5 protocol. There is the only layer 2.5 protocol is MPLS. So if anyone says ARP is a layer 2.5 protocol, that is like, I would say, completely incorrect. But there is like a lot of debate about like ARP, like is it a layer 2 protocol or a layer 3 protocol? In my opinion, what I have like read everywhere, I have read like in the RFCs, in the documentations, what I know, what I have observed, ARP is a layer 2 protocol. Because think about it, if ARP was a layer 3 protocol, I would see an IP header. Every layer 3 protocol that you know of has an IP header. ICMP, IGMP, EIGRP, OSPF, all these layer 3 protocols have the IP header. If you take a look at this ARP message is directly being encapsulated at the layer 2. Moreover, in the layer 2, we have this ether type field. Ether type field is used to tell the upper layer protocol. Ether type field is used to tell where the passage has to be handed over to. Ether type field 0x0806 means ARP. That means when the device receives this packet is directly going to be sent to the ARP. It is not going to be sent to the IP, because if it was being sent to the IP, this type will be 0x0800. So since this ARP packet is directly getting encapsulated at the layer 2, since in the layer 2 header I can see the ether type as 0x0806, which is to tell like the packet will be handed over to the ARP directly, not to any IP, I can safely say that this ARP is a layer 2 protocol. Then why people say that it is a layer 3 protocol? Because when you open this ARP packet, you see these IP addresses. So that's why people say that, okay, this is a layer 3 protocol, or since it is it uses the IP address to resolve the MAC address. By that concept, people say that it is a layer 3 protocol. And if you go by that concept,
typically we say ARP is a layer 3 because we always see that in the layer 3 device to check the ARP table, and the ARP table doesn't exist in layer 2 switches. That's why.
Yes, so exactly. But from the packets point of view, like when we see the packets that are getting generated, ARP table can exist it can exist on these layer, not exactly the layer 2 devices, but wherever we have the IP address, we will get the ARP. If you have configured an IP address onto the interface, we will get the ARP. So from that concept also, people refer to that ARP is a layer 3 protocol, because typically they see it in the layer 3 devices or any interface where we have configured the IP address, right? But from the packets point of view, if you take a look at the packets, from the packets point of view, if you notice that these ARP requests, ARP replies, these are getting generated at what layer of the OSI model, what layer of the TCP/IP model. These packets are generated by this ARP process and handed over directly to the layer 2 of the OSI TCP/IP model. So from that point of view, I'm saying that ARP is a layer 2 protocol. But from that point of view, that the ARP typically is seen on the layer 3 devices, it is used to map the IP to MAC. People also consider it as a layer 3 protocol. That's why I said, like, there is no clear indication of the ARP, like where this ARP protocol actually is used. So again, people assume it as at layer 2, people assume it at layer 3. And some people, like, they say that it is a layer 2.5 because it uses both of the things. So that's why some people say that it is 2.5. Both, I guess, like, both layer 2 and layer 3 is okay. From the packet point of view, if you think about it, it can be said as a layer 2 protocol, but from the operational point of view, like if you see that it maps the IP to the MAC address, can be seen on the layer 3 interfaces. From that point of view, of course, that can be considered as a layer 3 protocol. But if someone says that since it contains the IP address, based on that we are saying this, it is a layer 3 protocol, then by that concept I have DHCP packets which also contain the IP address. But I don't say that DHCP is a layer 3 protocol. We say that DHCP is an application layer protocol, because DHCP process generates the packet, gets encapsulated via a transport layer header, then the IP header. By that concept, if someone is saying that ARP is a layer 3, that might not be correct. From like where the ARP operates, from where the ARP messages are generated, based on that we can say it is either layer 2 or layer 3. However, there is still no clear indication. From the packet point of view, since ARP messages are directly encapsulated by layer 2 header, from packet point of view, I say that ARP is a layer 2 protocol. From the operational point of view, we can say that it is a layer 3 protocol. Now same thing will happen here as well. Same thing happen, like if I configure the IP address and everything here, same thing will happen here as well. So I'm again not going to do the capture at the moment. I'm just going to configure the IP address on the router 2, and I'm going to configure the IP address on route server number 1. So configure terminal, interface FA0/0, IP address is going to be 192.168.3.2 as per the topology. No shut. Same process will happen here and here, and as per the topology 3.1, and as per the topology I will configure the IP 3.2 on the server. So I will go to the server, interface FA0, on the router, configure terminal, interface FA0/0, no shut, IP address 192.168.3.1 255.255.255.0. So same process will happen now here as well. Devices will try to resolve. Devices first of all will try to see if we have a unique IP or not. Once they confirm that they have the unique IP, those IPs can be used to send the traffic in a unicast fashion from one device to the other device.
I think we need to disable the routing on the server as well.
Yeah, it's just a second. I will go to the server, and of course I'm going to see no IP routing, so that routing gets disabled. And now coming to the point, here we have configured the IP of 192.168. Here we have configured the IP 192.168.1 subnet. Okay, so here we have configured the IP 192.168.1 subnet IP. Here we have configured 192.168.2 subnet IP, right? And so this device, this PC, can reach to any IP address in this broadcast domain directly. This server can reach to any IP address in this broadcast domain directly. So if I had like another device, such as here, if this device wants to reach to this device, it can go directly there. If I have another device here, if this device wants to reach to this device, it can go directly here. But if this device wants to reach to this device, or if this device wants to reach to this device, they cannot communicate directly, because this IP does not belong to this range and this IP does not belong to this range. So when we want to send the traffic from like one broadcast domain to another broadcast domain, from the end user point of view, we need to configure the default gateway. So I will go on the PC, I will go on to this PC, which is again in our case just a router. I have already disabled the routing capabilities here. So I'm going to say IP default gateway, and which is going to be 192.168.1.1, the IP address of the router. So IP address that we have configured on the router will act as the default gateway for this PC, and IP address configured on the router will act as the default gateway for the server. So whatever IP address we have configured on the router, this router will act as the default gateway for this broadcast domain, and whatever IP address we have configured on this router will act as the default gateway for this broadcast domain. So the command on the device is IP default gateway, which is equal to, this is equal to giving a default route onto the router. So IP default gateway 192.168.1.1, IP default gateway 192.168.3.1. And of course, I can do the, if I have configured the correct IP, of course I can do the ping 192.168.3.1 and the pings will be successful. Yes, Ravi. Any questions? Not able to hear you, Ravi, just in case if you are saying something. Use the chat box just in case if you have a question, because I'm not able to hear you. Now, when we do the ping from this server to this IP address, when we ping from this device to this device, when we ping from 192.168. When we ping like from this server to this router, this on the server, the IP address that I have configured, it is 3.2, and the IP address that we have configured on the router, it is 3. So it is 3. It is 3 subnet. 2 is here actually. Okay, so now if I go to this server and try to do the ping to 192.168.3.1, which is my default gateway, again the point remains the same. When you do the ping, what happens actually? Ping is a process that uses ICMP protocol. So this device, as soon as I do the ping, this device is going to generate an ICMP echo request packet. This ICMP echo request packet will be encapsulated, since ICMP is a layer 3 protocol. This ICMP echo request packet will get encapsulated by layer 3, which is like IP. At the layer 3, it will get encapsulated via IP. Here it will add the source IP, here it will add the destination IP, and one more important thing that it will add is the protocol number, and one thing that it will add is going to be the TTL, the IP header. Since we are using IPv4, the ICMP packet will get encapsulated via IPv4, and IPv4 is going to add the source IP, IP4 is going to add the destination IP, protocol number, TTL along with the other fields, but these are some main fields that we have to see. Now the destination IP is going to be 192.168.3.1. That's okay. Protocol number is going to be 1. Protocol number specifies what is being encapsulated. So since ICMP is being encapsulated by IP, ICMP has a protocol number 1. ICMP has the protocol number 1. So the protocol number is going to be 1 in this IP header. Protocol number lets the devices know what is being encapsulated inside this IP header. So that is 1. TTL again is going to be 255, could be 128, could be 64. TTL is just a number which defines like how long this packet can live in the network. We'll talk about that in a moment. So devices, like whatever TTL is implemented on the device, that TTL will be used. If the TTL settings are 255 onto the device, then the TTL will start from 255 and then it will keep decreasing like one by one as soon as the packet crosses the router. So TTL starts from 255. In some implementations, it can start from 128. In some, it can start from 64. Different implementations of the devices use different TTL settings. Here we are assuming that the TTL is going to be 255. The problem is that while doing the ping and trace, while doing like ping, trace, telnet, SSH, whatever, we do not specify the source IP. I have not specified the source IP. I am just saying ping and I have just specified the destination IP. I have not specified the source IP. Remember that if you do not specify the source IP while doing the ping, trace, SSH, telnet, whatever, if you do not specify the source IP, the device will automatically add a source IP into the packet. And that source IP, which is going to be added into the packet, the source IP will be the IP address of the exit interface towards the destination. So on my server, if I had multiple network interface card, and this network interface card is going towards this, for example, destination 192.168.3.1, that IP address will be used as the source IP address here. Source IP address is the IP address of the exit interface to reach to the destination. So since I'm trying to reach to 192.168.3.1, to go to 192.168.3.1, I'm going to use my FA0 by 0 exit interface. Whatever IP address we have configured on there, that IP address will be used as the source IP automatically. You don't need to specify it. If you want to specify it, of course, you can specify it by mentioning here, by mentioning the source keyword 192.168.3.2. You can specify the source. You can specify the source interface. You can do all those kind of things. But if you don't specify the source IP is going to be the IP address of the exit interface towards the destination. Now, this packet for further processing will be handed over to the data link layer. At the layer 2, data link layer is going to add the Ethernet header and the Ethernet trailer. Ethernet trailer contains CRC, which is for error detection. No need to worry about it. In the data link layer header, the important things, the important fields that will be added is going to be the source MAC address and going to be the destination MAC address and ether type. Ether type field lets us know what protocol is being encapsulated by this data link layer header. Source MAC address is of course your own MAC address. The exit interface MAC address will become the source MAC address. Considering the exit interface MAC address is A, that MAC address will become the source MAC address. Ether type, since it is IPv4, 0x0800, fixed for IPv4. Now we don't have the destination MAC address. Destination MAC address is the MAC address of the, always remember, destination MAC address is MAC address of the next hop, not the destination itself. Destination MAC address, don't get confused by the name. Destination MAC address is always the MAC address of next hop. Destination MAC address is always the MAC address of next hop. Since we are trying to reach from 192.168.3.2 to 192.168.3.1, both sender and receiver, they belong to the same subnet. That means I can reach from the sender to the receiver. I can send the traffic from source to the destination directly. I don't need to go to any gateway. I don't need to go to any router. That means my next hop is the destination. Next hop is the destination in this case. Since the packet is being sent in the same broadcast domain, the next hop is the destination. The next hop, the next stop of the packet is in fact the destination. So the MAC address of 192.168.3.1 will be added as the destination MAC address in the data link layer header. Now the problem is that on this server, I have all the information, but I do not have the information about the layer 2 destination MAC address. I don't have the MAC address of 192.168.3.1. I have source IP, I have destination IP, I have source MAC, but I do not have the destination MAC information, which means like I cannot encapsulate that packet. I cannot encapsulate that packet and I cannot send that packet towards the next hop, towards the next device. Okay. So this device is going to buffer that packet, that ICMP, that IP. The packet is going to be sent into the buffer memory of the device, and the device is going to generate an ARP request. This device is going to generate an ARP request for 192.168.3.1. That ARP request is now going to resolve the MAC address of 192.168.3.1. Since 192.168.3.1 is my next hop, it is where I'm going to send the packet, I need the MAC address of that particular device itself. So the device is now going to generate an ARP request for 192.168.3.1. That ARP request will be broadcasted, will be received by everyone, but only the device that receives this ARP request message, this device is going to decapsulate that ARP request message. This device is going to take a look at the target IP of the ARP request message 192.168.3.1, which is matching with the receiving interface IP address. So this device will know that this ARP request is for me and I have to send an ARP reply. So the target IP in the ARP request message is matching with the interface IP address that we have configured here. That is how this device comes to know that it actually has to send the ARP reply for that ARP request message. So this device is going to generate an ARP reply. That ARP reply is going to be unicasted towards the sender, and then this device will come to know the MAC address of 3.1. Once it knows the MAC address of 3.1, it is going to maintain that information in an ARP cache for 4 hours by default, so that for next 4 hours, it does not need to send the ARP request and reply again to resolve the MAC address of the next hop again and again. So for next 4 hours, the communication can be done without sending the ARP request and reply again and again. So let's see. Let's go to this server. Let's go to this server. Let's do the ping. Let's do the ping. Ping is successful. I can see no packet drops here. The ping is successful, 192.168.3.1. If I take a look at the packet captures, which I did not do. Okay. So let's go on the PC number 1 then. I actually forgot to do the packet capture here anyway. So let's go to the PC number 1. Let's go to here, the PC number 1. On the PC number 1, I will do the same thing. I will ping 192.168.1.1. So ping is successful here as well. If I take a look at the capture here, just take a look at the capture here. In the capture, you will notice the first process that happened was the ARP message, the ARP process. Then ICMP messages were sent. If you take a look at this capture, if you open this ARP request message, this is the ARP request message which is sent by the PC1. The opcode 1 means the ARP request. Hardware type will be the Ethernet, protocol type will be 0x0800, which is basically that this is an ARP request for IPv4. A sender MAC address is the MAC address of the PC, sender IP is the IP address of the PC, and the target MAC address is 0000, and the target IP is 192.168.1.1. Remember that in the ARP request, the target IP is 0000. It is not GARP, it is not ARP reply, it is ARP request. In the ARP request, target MAC address is 0000. So sender IP, sender MAC, target IP, target MAC. This is the content inside the ARP request message. This ARP request message got encapsulated directly by the layer 2 data link layer header. There we have source MAC address, destination MAC address. ARP request is always broadcasted. Source MAC address is your own MAC address. Destination MAC address is a broadcast MAC address. And then the data, then this ARP request packet was placed onto the data link on the physical media. This ARP request will be broadcasted. The switch will receive that ARP request. Switch will learn the source MAC address. Switch will check the destination MAC address. And since the destination MAC address is a broadcast MAC address, switch will flood that MAC address. Switch will flood that ARP request out of all the ports except for the port where the frame was received. Eventually, that ARP request packet will be received by the router number 1. As soon as the router 1 receives that ARP request, the very first thing that it is going to do, it is going to update its ARP cache. As soon as it does that, as soon as this router number, I did not send any packet from router number 1, but as soon as this device receives that ARP request, in that ARP request, and since the sender is already sending its IP and MAC address information, the very first thing this router is going to do is to update its own ARP cache. So this router has updated the ARP cache, that 192.168.1.2 has this MAC address, and on what interface I have learned about this IP MAC settings on the interface FA0x0, the encapsulation protocol is ARPA, Advanced Research and Project Agency. ARPA is the encapsulation ARPA is the protocol that is responsible to perform the encapsulation in the Ethernet technology. Advanced Research and Project. It's not ARP, it's ARPA, Advanced Research and Project Agency. And then this router number 1 is going to decapsulate that ARP request. Once the router 1 decapsulates that ARP, since it is broadcasted, it has to accept it. So this router number 1 remove the data link layer header. It comes to know that this is an ARP packet. When the router receives this packet, once the router receives this frame, if I say frame, the router is going to decapsulate that frame. The router has to accept that frame because the frame is being broadcasted, and since you are part of that broadcast domain, you have to accept that frame. Then the router is going to check the type. From here, it will come to know that this is for ARP. So it will remove this data link layer header, and it will pass that message to ARP process running on the router. The ARP process that is running on this router is going to open this information. It is going to see the target IP, which is matching with the IP address of the receiving interface. And by here it comes, of course, it will first of all create the entry in its own ARP cache. And then it will come to know that someone is asking for the MAC address of 192.168.1.1, which is my own IP address. So in response, this device is going to generate an ARP reply. You can see that this is the ARP reply sent from the device router number 1. This ARP reply was generated. In the ARP reply, the sender 192.168.1.1 has put its own MAC address, target IP, target MAC address. This ARP reply is being unicasted to the sender who has sent me the ARP request. So this ARP reply is being unicasted. Once the packet is received by the switch already has maintained the entry in its MAC address table. Based on the entries in the MAC address table, the switch will unicast that ARP reply towards the PC. And once the PC receives it, the PC is going to also maintain the information in its ARP cache. So first the ARP process gets complete, and then that ICMP packet will be taken out. That ICMP packet will be taken out from the buffer. It will be encapsulated with the source MAC address, destination MAC address, and now that ICMP packet, ICMP echo request packet will be sent from 192.168.1.2 to 192.168.1.1. If you open this ICMP packet, this is the ICMP echo request packet. Type 8 means echo request. We have some dummy data in this ICMP echo request. This is ICMP echo request packet, which contains 72 bytes of data, 8 byte for this header, which is like 80 byte in total. And then we have this ICMP packet got encapsulated by IPv4. This is the IPv4 header. In the IPv4 header, we have the fields called version, internet header length, DSCP, which is for quality of service, total length, identification, flag, fragment offset. These are fields in the IP header. The important field that we need to worry about is the TTL, ICMP, source IP, and the destination. That's what I'm saying. That's what I was talking about. If ICMP is a layer 3 protocol. Why ICMP is a layer 3 protocol? Because ICMP, why people say that ICMP is a layer 3 protocol? Because like ICMP, when it generates the packet, if you take a look at the packet capture, you can see that ICMP packets are getting encapsulated by IP. They are not directly getting encapsulated by the data link layer. They are getting encapsulated. They are being handed over to the IP protocol, and then from IP it goes to the data link layer. Since I don't see any IP header in the ARP message, that's why I personally do not think that ARP is a layer 3 protocol. In my opinion, from the packet capture point of view, you will notice that ARP is a layer 2 protocol. However, again, same thing. From the operational point of view, you can consider still it as a layer 3 protocol. Then again, the source MAC address, which is your own MAC address, the destination MAC address, the MAC address of the destination, and then the packet will be placed on the wire. The packet will be received by the router 1. Router 1 will send the ARP reply in the response. ARP reply has the type code type 0. So ARP request, ARP reply, then ICMP echo request, ICMP echo reply. that process will then get complete. So ARP happens first, and then ARP happens first, and then we have this ICMP packets going through. Same process will happen here. Same process will happen between like router 2 and server. Same process will happen here. So then you will be able to, of course, ping from this device to the gateway, this device to the gateway in the same broadcast domain. The same process will happen for all the devices, and you will successfully be able to ping from one device to other device. So far, any questions, anyone? Let me know. Any doubts? Just the basics.
Hello, sir. Just one basic question.
Yeah.
In between R1 and R2, why did you took serial cable instead of
I'm not going to answer that. Like, you know, R1, R2, you have to, because now I'm going to ask a question in between router 1 and router 2. I'm not going to answer that. That is my turn to ask the question now. Once you will find the solution to that question. If you don't, then I will answer it. Let me first put a question here. Then let's see if you guys can answer. If not, then you will find the solution. You will find the answer, and then, you know, if you don't, then I will answer it.
Fine.
So here and here, if you have any questions in these two broadcasts, then if you have any questions, then you let me know. Not in between router 1 and router 2, because now I'm going to ask a question.
Okay, sir, I want to ask one thing. Like we have the ether type 0 cross 0800. So are there different ether type for use, and what will be the changes if I change that ether code? Can I change it from myself?
These are like predefined. So if data link layer is encapsulating IPv4, the ether type is going to be 0x0800. If the data link layer is encapsulating an ARP message, it will be like 0x0806. And if it is like if the data link layer is encapsulating like IPv6, then it will be 0x86DD, right? And similar to that, other things can be there as well, such as like in case of MPLS, it could be different, templates, unicast. So these could be different. These are just to tell the upper layers, like, okay, this is what is being encapsulated. This is like from when the packet is received by the device, then the packet must know where I have to forward the packet. So for that, these are like more like predefined values that you have to memorize. At least you should memorize IPv4, ARP, and IPv6 for the moment. Later on, when we talk about MPLS or other technologies, these values, like, you know, be different actually.
Okay.
Coming to which?
Hello. Sir,
yeah.
Actually, one question is that actually few cases we observe that when we first configure the IP in like host or any server, and we try to ping the gateway, the first packet got dropped in few cases. Means here it is 5 packets.
Yes. That is like if you are trying from the PC point of view. Let's say, for example, here in ideally, like what happens when we generate the packet from these devices. If these devices have a concept of buffer, when we generate the packet from these devices like when I say like ping or trace or whatever, once these devices come to know that we don't have the destination MAC address, they put the packet in the buffer, and then they send the ARP request, ARP reply, and then they take out the packet from the buffer, and then the packet actually sends. So no packet drop. But sometimes what happens, like for example, in the situation, let's say, for example, here you will notice that if the device cannot, due to some reason, place the packet into the buffer memory, due to any reason, if the device cannot place the packet into the buffer, then when the packet reaches out to the data link layer, since in the data link layer we do not have the destination MAC address information, because there the packet will get dropped because of encapsulation failure. You will see that. I will show you that, but you will see that only when like the data link layer could not be able to encapsulate the packet. Then, like, you know, you see that one packet drop, which you will see here. If you had an Ethernet cable connected here and you do the ping from here to here, you will see that one packet will get dropped, and that packet will get dropped actually here, because when the packet arrives on the router and the router has to forward the packet from one interface to the interface, when the router has to perform the routing, it will actually not place the packet into the buffer. If it could not encapsulate the packet will get dropped actually. So that packet is not getting dropped here. That packet is getting dropped in the transit in between these devices actually.
Okay.
Okay. Okay, so ARP process is done. ARP process, now you know, and you know about this ICMP process, at least the basics of it. Now, coming to this point. Here, in between router 1 and router 2, I am using serial technology. Here I'm using a serial technology. Serial technology like serial cables are another way by which we can connect the router. Typically, serial interfaces, serial ports are available onto the router. And using these serial interfaces, using these serial ports, we can actually connect 2 or more routers together. Not very popularly, you might see these serial cables nowadays. Serial technology was more like a WAN technology. But since nowadays Ethernet standards have evolved so much that we can use Ethernet as a WAN technology nowadays. So use of the serial technology is not that much like in your production environment, but still here and there you might see the serial cables being used. The point is, in the serial technology, we had different protocols to perform the encapsulation. In the Ethernet technology, we had the protocol ARPA. In case of serial technology, we had different protocols such as, for example, HDLC, we had protocols such as PPP, we have protocols such as frame relay. We had different technologies, like we have different protocols at the data link layer that can encapsulate the packet that is being sent out of the serial interface. And HDLC, PPP, and frame relay, none of these protocols have the concept of the MAC address. Serial technology does not have the concept of the MAC address. In the serial technology, we do not have the MAC address concept. We have the MAC address concept in the Ethernet technology, but we do not have the MAC address concept in the serial technology. Okay. Why we don't have the concept of the MAC addresses on the serial technology and have the same on the Ethernet technology? Because Ethernet technology that we have, it is a multi-access technology. Ethernet technology is considered to be a multi-access technology where multiple devices can connect together with the help of the Ethernet technology using a device such as, for example, a switch. We actually need to uniquely identify the sender and receiver. We actually need to uniquely identify the sender and receiver in a multi-access network. If you do not uniquely identify the sender and receiver in a multi-access network, your packet cannot be delivered from a sender to a destination. In a multi-access technology, since multiple devices can access at the same time the network resources, so we need to uniquely identify the sender and receiver. For that purpose, in a multi-access technology, we have that concept of the MAC address. But on the other hand, the serial technology is more like a point-to-point technology. We cannot have this. We cannot have this. We cannot have this kind of topology. This switch is known as Ethernet switch for a reason, because it supports Ethernet technology, not the serial technology. Serial technology typically is used in a point-to-point scenario, like here, something like this, in a point-to-point scenario. So we connect 2 routers in a point-to-point manner with the help of this serial technology. So it is obvious, it's obvious that if the packet is being sent from this device, from this interface, the packet can only be delivered onto the other end. This is since it is a point-to-point connection, it is obvious that when the packet exits this interface, it will 100% be delivered on the interface serial 3x1 of the router number 2. There is no need to uniquely identify the sender and receiver in a point-to-point technology. They do not have the concept of MAC addresses on the serial technology. But then they created these specialized switches. These switches such as, for example, frame relay switches. Switches such as, for example, ATM switches. These switches such as like frame relay or ATM, specifically like, especially we are talking about this, if we talk about this frame relay switches, these switches do have the serial interfaces where it is possible to connect multiple routers in a point-to-multipoint fashion. But still, we do not have the MAC address on the serial interfaces. Even if you connect like these routers with a technology such as frame relay, where like multiple routers can connect all together, with the help of the serial technology in a multi-access kind of network, still we do not have the concept of MAC address onto here. Serial interfaces, basically they do not have the MAC address. Not when we connect in a point-to-point manner, not when we connect in a point-to-multi-point manner. When we use to configure the frame relay devices, there we need to configure additional things such as, for example, DLCIs, data link connection identifiers. These used to work as the MAC address for these individual connections. DLCIs were the numbers by which the frame relay providers like these devices switch the packet from one of its interface to other interface, from one of its interface to the other interface. DLCI is like we had like a lot of concepts on the frame relay such as DLCI, then we had like LMI, FECN, BECN. We had like different concepts in the frame relay technology. No need to worry about it because we will not see it. The point is that in the serial technology we do not have the concept of the MAC address, because it's obvious that when the packet leaves this interface, it will be received onto this interface. It will be, but this is not so obvious in case of Ethernet technology, because by using Ethernet switches we can connect like multiple devices at the same time, and there now we need to uniquely identify the sender and receiver. So in Ethernet technology we have the concept of the MAC address, but in the serial technology we don't have the concept of the MAC address. And since we don't have the concept of the MAC address, we do not require any ARP protocol. So if I do the packet capture here, now the question is, if I do the packet capture here, it gives me the option to, it gives me the option like what protocol do you want to capture on, SDLC, PPP, frame relay. Since I know that by default it is SDLC. By default, the data link layer encapsulation protocol on the serial technology is SDLC, high level data link control. Again, no need to worry about it. You can, if you want to confirm it, you can go on the router. You can use the command show interface serial 3x1, 3x0. You can see show interface serial 3x0. You can see that the encapsulation here is SDLC, and you can use the command show interface FA0x0. You can see that here on the FA0x0, the encapsulation is ARPA. So on the serial technology, also on the data link layer, on the FA0x0, I can see the MAC address, but if I go on the serial, I do not see any MAC address because we don't have the MAC address concept on the serial interface. So now my question is, if I know that there is no concept of ARP in this serial. ARP is used for MAC to IP resolution, IP to MAC resolution. But since we don't have the MAC address, we do not require ARP on here. So if I go on router number 2, here on the router number 2, if I go on the interface serial 3x1, no shut, and if I configure the same IP address 192.168.3.1, will we get any message that a duplicate IP is there, or will we not get any message? If you don't get any message, how will we know that the same IP address is configured on both the ends? Is there any mechanism? Yeah.
We do not get the duplication here because it is not directly connected to any device to communicate through that interface.
Okay. But in our case, like router 1 and router 2, like we have connected them via serial technology. We configured the IP address on one end, did the no shut, and now I'm trying to configure the same thing on the other end. So there is a P2P connection between router 1 and router 2, just like we have the connection.
Yeah, but the exit interface is like so as this is a router, so each interface or exit interface is acting like individually. So this is the only is serial 3/1 is communicating with the router 1 and serial.
But same thing. Yeah, same thing. Like let's say for example, same thing from the same concept point of view. If I go on this router number 2, I configure this on like FA0x0. I configure the same IP The device uses the R process to find out like is if the IP that I have configured, even if I do a P2P connection on this interface, if I connect like directly like with the PC, the R process will happen as it is. So do we have any mechanism by which these devices can come to know that what IP we have configured on the other end is the same IP that I'm trying to configure on my end, or we don't get any log? So is it possible that we have the same IP address on both the ends on the router and things still work fine? What exactly is going to be there? If you don't get the logs, if you do not get the logs, then is it possible that we have the same IP configured on both the interface? Will we be able to ping or not?
No, we cannot.
Okay. So yeah, exactly. So those things you will find out. You just have to hit enter. You will find out, will you get any log? You will do the packet capture. You will see what is going on in the backend. Does this HDLC, triple P, does this protocol has any mechanism by which the duplicacy can be checked by on the router exactly the similar way as it was checked on here? Those things like you will check from your side. I'm not going to do that. I'm just going to configure the IP address to 2.2, 192.168.2.1 on one end, and I'm going to configure 192.168.2.2 just for the confirmation. If I hit enter here, if I take a look at here, I do not see any ARC message. Just like we used to see the ARC messages on the interfaces when we configure the IP, we do not see anything here. So now it's your turn to find out, can we configure the same IP on both the end? If I do that, do we get any log messages? If we don't, then how the devices will come to know that there is a duplicate IP in this P2P, in this serial technology environment? Do we need to like find that out manually? Since it is a point-to-point connection, it's not going to be a problem. We need to find that out. Will the ping work and all that? Well, you can do all the kind of testing there. But one thing is confirmed: you will not get the log messages. You can still do the ping. I can go on this router. I can say ping 192.168.2.1. Ping is successful. You can take a look at the capture. There is no ARC process here. Just 192.168.2.2 generates the ICMP echo request packet. It encapsulates that ICMP echo request packet in the IP header, and it is being encapsulated directly by the SDLC protocol. There is no such field such as like source MAC address, destination MAC address. This is just the type and the protocol number 0x0800. Bit by bit, the device, once it receives the packet, once it encapsulates that packet, it is going to forward that packet to the physical layer. Bit by bit, that packet is going to be transmitted, assembled, same thing, like encapsulation, decapsulation process will happen, and the packet will be delivered on the other end without the need of any ARP message here. So in SDLC, we do not have the concept. In triple P, we do not have the concept of MAC addresses. Since we cannot have the point to multi-point scenario in case of serial technology, ideally, we do not require the unique identification for the sender and receiver. Sender can encapsulate the packet, place it onto the exit interface, and it is guaranteed that the packet will be delivered on 3x1. 3x1 will decapsulate it and forward that packet towards the appropriate upper layer protocol. In our case, the upper layer protocol is IPv4. IPv4 will decapsulate it, check the protocol number. Based on the protocol number, it will come to know that it is ICMP. Then it will forward that packet towards the ICMP. ICMP will see it is a echo request. It will send echo reply based on the same. Rest of the process will happen exactly the same way. Just there is no ARP, there is no source MAC address, destination MAC address concept in serial technology because it's not required. Fine then. Now finally, I do the ping from PC to server. If I do the ping from PC to server, let's go on the PC number 1, and finally let's try to do the ping from PC to the server. Let's go to the PC and try to ping. Since we have configured IP address everywhere, I can say 192.168.3.2. I'm trying to ping from the PC to the server. I hit enter. I just get a message U. U means unreachable. U, that the message that I'm getting here, U means unreachable. So if I go on this PC1, if I take a look at those captures, if I go to the PC1, the capture that I did earlier. So what happened? The device, the PC1, generates the ISMP echo request packet. This ISMP echo request packet actually has the same information, ISMP echo request type, then it has like data, it has like code, everything looks like exactly the same. Remember that everything that you see in this bracket, in this big bracket, everything that you see in this bracket, it is only in only in Wireshark. It's not in real. Everything that you see in this big bracket, it is only in Wireshark. It's not in real. It is not part of real packet. It is just in the Wireshark. It's just the Wireshark way of telling you that I did not see any response for this packet. So the device generates the ISMP echo request, encapsulates it with the source IP, destination IP, encapsulates it with the source MAC address, destination MAC address, forwards the packet towards the router. Once the packet is received on the router, router receives the packet, router decapsulates the packet. Remember that source IP, remember that source IP, destination IP, source MAC, destination MAC. Source IP, destination IP, source MAC, destination MAC. Destination MAC, remember, is always the MAC address of the next hop. And if you want to go from here to here, your next hop is your gateway. So the destination MAC address will be the MAC address of the default gateway, not the destination. So source IP, destination IP, source MAC, destination MAC. Packet was sent to the router. Router decapsulated that packet, removed the data link layer header, checked the destination IP. Router number 1 found out that the destination IP is 192.168.3.2. Unfortunately, on router number 1, we do not have any route to reach to 192.168.3.2. The only route that we have in my routing table, it is 192.168.1, 192.168.2, which is directly connected onto the interface 0x0 and directly connected on the interface 3x0, which also gives you the idea. Right from here, you should understand that as soon as we configure the IP address on any interface, immediately the router is going to maintain the information in the routing table. As soon as we configure the IP address on any interface, the router will immediately, you configured the IP. You configured the IP 192.168 dot whatever. You have configured the IP address on the router interface. As soon as you configure the IP address on the router interface, router will run the algorithm. Router will find out what is the network ID using this IP address and the subnet mask. Just like you can find out the network ID, the router can find out the network ID from this IP and subnet mask, and it will maintain that route information, that subnet information in the routing table. So directly connected networks are always there. And also remember, these routes will only be there in the routing table as long as the interface is up. If the interface goes down, those routes will also be down. The routes learned on the interfaces are only there on the routing table until the interface is up. So if the interface goes down due to any reason, if the interface goes down, the route entry is also going to be removed from the routing table. So at the moment, I can say that the router has learned a route on the FA0x0. At the moment, I can say that the router has learned a route on the serial 3x0. That route is directly connected. That route is directly connected. Also, whatever IP we have configured, that IP information is also maintained in the routing table with the keyword L, keyword L. So this router actually has no route to reach to 192.168.3.2. So this router, once it receives that ISMP echo request packet, since the router cannot forward the packet towards the destination, it has sent a message. It has sent an ICMP message from 192.168.1.2, means the router, to the host. It sent an ICMP message. That ICMP message is destination unreachable message. The type 3, ICMP type 3 is destination unreachable. Code 1 means host unreachable. This ICMP message reports that I cannot reach to that particular destination because I don't have any information on how to reach to that destination. So U, the code, the error, the code U that you saw here, U basically means unreachable. So I need to go on router number 1. Somehow I need to provide a route on here, IP route 1 static route. I'm going to configure on router number 1 a static route to reach to 192.168.3. I'm going to go on router number 2. Okay, first let's configure on router number 1 a route to reach to router number 3. Basically 192.168.3. So just the basic static routing. Hopefully you remember it from your CCNP studies. So IP route, destination network, mask, and since I know that the only thing that this router cares about is the exit interface, the only thing that I will mention is the exit interface. I know that the router only cares about the exit interface, so I will mention only the exit interface while configuring the static route. More on a static route later on in a static routing class. So on router 1, since I knew that the router did not have a route to reach to that destination, I went on router 1 and I said that if you want to go to any IP from this range, exit out of the interface 3 by 0. Now do the ping again. Now do the ping again. This time we are not getting U. This time we are getting drops simple. So this PC is generating these ICMP messages. It is sending those ICMP echo requests. This time the ICMP echo request is received by the router. The router decapsulates those ICMP echo request message. The router checks its routing table. Do I have a route to reach to 192.168.3.2? Yes, I do have a route to reach to 192.168.3.2. If I need to go there, I need to exit out of the interface serial 3 by 0. So the packet will be placed from FA 0 by 0 to serial 3 by 0. And while packet is getting placed on 3 by 0, encapsulation will happen. The router will perform encapsulation. So those packets will be encapsulated now with HDLC here. HDLC, high level data link control, the HDLC protocol. If you open this packet, you can see that this ICMP echo request packet was encapsulated by the HDLC. And of course, I don't need to tell you that the TTL will be decremented by 1. When the packet moves from one network to another network, when the packet crosses the router, when the packet leaves the exit interface, the router is going to decrement the TTL value by 1. TTL is always decremented by 1. A packet was received by router number 2. Router number 2 has now the responsibility of router 1 is done. Router 1 is no longer responsible to make sure that if I get the reply or not. Router 1's responsibility is done as soon as the packet leaves the interface serial 3 by 0. Now the packet is received on router number 2. Router number 2 will decapsulate the packet. Router number 2 will see, do I have a route to reach to 192.168.3.2? Do I have a route to reach to 192.168.3.2? Yes, actually, the 192.168.3.2 is directly connected out of the interface FA 0 by 0. So now the router is going to place the packet from serial 3 by 0 to FA 0 by 0. When it places the packet on FA 0 by 0, that ICMP packet will again be encapsulated with the data link layer header. This time it is the Ethernet header. And since the Ethernet header requires the source MAC address and destination MAC address, the router will put the source MAC address and put the destination MAC address. If I do not have the destination MAC address, I will send the ARP request, ARP reply, and I will get the destination MAC address. And that first packet will be dropped here. The first packet, the very first packet will get dropped. The very first packet will get dropped because encapsulation failure. Because I did not have the destination MAC address information, so I could not encapsulate the packet at layer 2. So because of the encapsulation failure, the packet will get dropped. But since we already did the ping, when we did the ping, the ARP process also completed automatically. So the source MAC address and destination MAC address was mentioned properly, and the packet was sent to the server. Server receives that packet. Server decapsulates that ICMP echo request packet. Server finds out that this ICMP echo request packet is for this device itself. So this device is going to generate an ICMP echo reply. Unfortunately, when the ISMP echo reply comes on router number 2, router number 2 actually does not have a route to reach to 192.168.1.2. Also, I don't need to tell you that when you send the packet, this is the source IP, this is the destination IP. When the reply comes back, this will become the source and this will become the destination. So 192.168.3.2 becomes the source IP, 192.168.1.2 becomes the destination IP. Packet arrives onto the source MAC address, destination MAC address. Packet arrives onto the router. Since the router does not have a route to reach to 192.168.1.2, packet actually got dropped when it was returning, because we do not have the return route, we do not have the reverse route on router number 2. So packet actually got dropped here, and since that ISMP packet I sent, it has a timeout, that if within this time period I do not receive the ICMP reply, echo reply, then I will consider those packets as timed out. So this is request timeout, request timeout, request timeout, that I sent a packet but I did not get the reply. So now you need to go to the router, you need to say that if you want to reach to 192.168.1.0 to 55.0 serial 3x1, once you configure correct IP address here, once you configure the correct IP address here, now when you do the ping and trace, now that ping and trace should be successful. Now the ping is successful. You can see the first capture. This is the very first capture, ISMP echo request. This was the second capture, ISMP echo request. This is the third capture, ISMP echo request. The packets, ISMP echo request messages, these were sent. The device sends the 3.2 sends the reply. Of course, the TTL will get decremented. You can see TTL get decremented. 255, the TTL was 255. Then we have the TTL of 254. Then we have the TTL of 253. So every time the packet crosses the router, this was 255, then 254, then 253, then 255, 254, and 253. So you successfully got the reply, and your routing process is done. These routers, they decapsulated the packet, take a look at the routing table, and based on that, they decided to forward the packet from one interface to other interface. While forwarding, again, they had to encapsulate, then decapsulate, then encapsulate, then decapsulate, encapsulate, decapsulate, encapsulate. The process will complete, and your ping and trace will work. These packet captures will show you like how the packets are being sent and received. And just to prove the point, let me go to router number 2 quickly. Let me go to router number 2 quickly. Let me go to router number 2. Interface FA0/0 shut. I did shut down on this interface, and I did the no shut onto this interface. When I do shut down onto the interface, when I do the no shut down on the interface, I went on this server. Onto this server, I said like shut, and no shut. By doing the shut and no shut onto these interfaces, I cleared the ARP. I cleared the ARP cache. I could have used the clear command as well, but on the interface FA0/0, if I shut down this interface, I can notice that the ARP entries get cleared as well. You can see there is no information. There is nothing here in the ARP cache. You can see that here also nothing is there in the ARP cache. I will go on router number 2, debug IP packet, maybe detail, debug ARP, debug IP packet, debug ARP. I went on the PC and I pinged again. Remember, here everything is okay. Here we don't need everything, but here on router number 2 and server number 1, we still do not have any ARP cache entries. This router does not know about this PC. This server does not know about this MAC address of the router. So if I ping again, now your point, one packet got dropped. This packet did not get dropped here. This packet did not get dropped here. 100% this packet got dropped on router number 2. When the packet was received on the router number 2, it decapsulated that packet. It found out that the destination IP is 192.168.3.2. In order to go to 192.168.3.2, I need to place the packet on the interface FA0 by 0. When we place the packet on the interface FA0 by 0, since it is an Ethernet technology, I need to put the source MAC address, destination MAC address. I take a look at my ARP cache. I do not know how to go to 192.168.3.2. So I could not encapsulate the packet. I could not encapsulate the packet. So the packet got dropped. Here. It says creating an ARP entry. It says creating an ARP entry for the packet. Then it sent the ARP request. Then it received the ARP reply. Once it sent the ARP request, once it receives the ARP reply, then the ICMP packet will be sent. Let me do it again. Let me do it again. Just a second. Actually, why I'm not getting these like this IP messages, because actually here we are running these things like Ceph. No IP. We'll talk about it later on. No IP route. Basically, packet is not even hitting the routing table. Okay. So what I did here, I actually disabled Ceph technology. We have Ceph technology running here. So what I did actually, I disabled the Ceph technology and I disabled the fast switching. Basically, I disabled these technologies, and then I'm going to again do the same thing like shut no shut. I'm basically trying to show you like the encapsulation fail message. So just quickly let me do the ping again. Okay, so let me quickly do the ping again. So I'm sure here, right here. So what happened? This is the first packet that I received. This is the ICMP echo request packet that I received from 192.168.1.2 to 192.168.3.2. This ICMP echo request packet could not be forwarded because of encapsulation failed. At the layer 2, the packet could not be encapsulated. So because of encapsulation failure, the first packet got dropped. And immediately the device sends an ARP request and ARP reply. The device sends an ARP request, ARP reply, and so that the next packets that we have, those next packets can be sent and received properly. Right, so right here, from here you can see that because of encapsulation failure, the one packet got dropped. Actually on here, same process could have happened here as well. So because of encapsulation failure, you can see that some packet, like 1 or 2 packets, get dropped, and then ARP request and ARP reply process completes. Once the ARP request ARP reply process gets completed, the rest of the packets get successfully delivered. So the packet does not get dropped here. Packet actually gets dropped at the point where the data link layer information, where the MAC address information is not present. If I had the serial technology instead of serial technology, if I had the Ethernet technology here, so one packet will get dropped here, one packet will get dropped here, and then the rest of the packets will get delivered successfully. So this debug output show you that the packet got dropped because of encapsulation failure at the layer 2. Since the packet could not be encapsulated, the packet got dropped. So this is like the whole routing process, which you can now refer to from this diagram. Like same exact thing that we covered. So if you do the ping from one device to the device, what process actually happens, we have discussed about that thing. We'll discuss a little bit more about it. We'll try to do the telnet SSH as well, so that we see the packet flow from the very top of the OSI model. That thing we will do tomorrow. For today, that's it. This is all that we will talk about. And you can now revise these things from the recordings, and you can do a similar lab like this in the GNS software.